My focus has been related to lead and PFAS. So I will introduce our next speaker who will be speaking about PFAS. So Graham Peaslee is a professor of physics at the University of Notre Dame, by the way, my alma mater. He leads an active research group in applied nuclear science where he brings established nuclear measurement techniques to pressing environmental issues. This includes a rapid detection of total fluorine as a surrogate for PFAS and screening environmental samples and consumer products to understand their fate and transport. He has over 230 publications, most with student co-authors. He earned his bachelor's degree in chemistry from Princeton University, and a PhD in chemical physics from the State University of New York in Stony Brook. Welcome, Dr. Peaslee.
Well, thank you, Beth, for the kind introduction. Let me see if I can share a screen here at the same time. Oh, I can now. That's good. We're going to go here and share that. And hopefully I can put that up as a slideshow. All right. Can you confirm that you can see my slides?
Yes.
Yeah, excellent. Thank
you. Great.
And that you can hear me. Wave if you can't hear me. I apologize for not being there in person. I really wanted to be, but the schedules, gods coincided and we didn't happen. But I'm happy, very honored to be able to present what I know about PFAS as what is now known as the forever chemicals. They are also, in my estimation, probably the largest contaminant the U.S. has ever had to clean up. It's going to be the most expensive contaminant, certainly, that the U.S. has ever had to clean up. And then the flip side of that is, of course, the public health concern for these chemicals and their availability. So I'm going to talk a little bit about that today. What are PFAS? And most of you will probably know some of this, but I will start at a basis so we can all talk about them. They're per and polyfluorinated alkyl substances, a mouthful, but they are a whole category of now over 12,000 of these things that have class numbers that we know what exactly they are, and probably thousands of others we don't know. They were all man-made. They were developed commercially as a result of one of the World War II projects. They used to be called perfluorinated compounds. Now they've moved to PFAS, which is the correct name or a better name for them. And the typical moniker is the forever chemicals because these have remarkable longevity. They have, they're tremendous surfactants. So they're used primarily as a surfactant role, which means a type of soap. They align the interface of air and water or air and oil or water and oil very nicely. They're used in everything, carpets, papers, cosmetics. You can see a little diagram below of the Scotchgard on carpets or the firefighting foams or the Gore-Tex jackets or the Teflon pans or even the microwave popcorn bag. You might wonder why a microwave popcorn bag uses a surfactant. Well, those of you who have been in graduate school know that when you cut the microwave popcorn bag open after cooking it, the first thing that comes out is steam. And you might wonder what that's doing in a paper bag. Why doesn't the bag get soggy? Well, we line the inside of the popcorn bag with fluorochemicals, which have a nonpolar end that likes butter. We put a bit of butter in there and we heat it at 200 degrees, and then we eat it. And you might wonder if that's the best place to put your man-made chemical. That's what I'm going to address. There are more than 200 uses. This review paper in 2020 came out with a beautiful list of all the patents and where they're used. Over 200 commercial uses with over 1,200 identified PFAS in use. What makes them so good? Why do everybody use them? This is a typical molecule. This is the PFOA, which you'll see a lot in the news. It's a C8. It's got 8 carbons and an end group that's polar and a nice non-polar part. It lines the water-air interface or the water-oil interface beautifully. And it makes this wonderful surface tension, so everything beads up on it. So it's a wonderful water-resistant chemical or oil-resistant chemical. And it's due to the fact that it has really strong carbon-fluorine single bonds, the highest bond energy for a single bond in the whole periodic table. You have to have a double or triple bond to get more energy than that. So these things are incredibly hard to break. That's also the problem. These things are incredibly hard to break. Therefore, they have environmental lifetimes in the hundreds, if not thousands of years, some of these chemicals. There are a basis set that don't break down. There are larger ones, more complex ones that do break down into the simpler ones. But as a result, there are no known biotic or necessarily abiotic degradation pathways for most of the basis set of the small chain or the C8 and below chain PFAS don't break down with anything that we can normally find. There's no energy to be gained from eating that bond, so none of the microbes will work to digest this. That leads to an incredible environmental persistence. And that means in this text and this figure here, that where PFAS are manufactured, they end up in the waste stream, they end up in the water, but more importantly, in the consumer products, they end up contacting the person, but they will also end up in the waste stream, will end up in the water. The water is used for irrigation that can come back to the human, or the water can be the most likely source of all our PFAS in our bodies is drinking water, because we do need to drink water. Though there are lots of different ways to get in, the fact that these chemicals continue to cycle through our system means that they're very persistent organic pollutants. They pile up in the poles on this planet because they last so long that they can last the 40-year journey up to the North Pole and the South Pole. This is the extent of contamination that the Environmental Working Group came out with a few years ago, and it shows that clearly it's only Michigan, New Jersey, and a few other states like Colorado and California. What that means is you haven't really started looking. The more presumptive contamination sites is wherever you find an airport, wherever you find a military airport, you'll find a lot of this. You'll find all military sites have it. Wastewater treatment plants concentrate it. And this is a more realistic expectation of where we're finding PFAS in this country, even though we haven't looked everywhere. And it's enormous. We have never seen such a water-soluble, persistent chemical as PFAS in our waterways. And of course, it has a wonderful property of bioaccumulating and biomagnifying in various ways. We have observed the polar bears with 88 parts per billion PFOA in their blood. I don't want to be the one collecting that sample, but somebody did, and that's what we observe. And that's reflective of a chemical that can last for a long time in the environment, migrate. The polar bears don't eat a lot of microwave popcorn, but they do eat the seals, that eat the fish, that eat the small fish, that eat the krill. And the Navy has been pouring this firefighting foam overboard for 60 years because they were told it was safe as soap. Not so true anymore. And so these types of, of course, the top predator in the mid-latitudes is the humans. And everybody in this room, or in that room, has on average 5 parts per billion of these chemicals in their blood, courtesy of DuPont and 3M so far. Those are 2 American manufacturers of about 6 total manufacturers. And there's no other way to explain it. The last blood that we have found without PFAS in it was from a Korean War blood bank, 1950s. Everybody since that time has had some of this in their blood, and some of the C8s are now going down as they're phased out in use, but there's even larger and wider use of the C6s and other replacement PFAS, none of which have been proven to be safe. In fact, most of them have these types of, if you're talking about disease outcomes, these are the adverse health effects known to be associated with PFAS so far. Liver and thyroid function dysfunction, they're endocrine disruptors, they're hypertensive agents, or preeclampsia is a pregnancy-induced hypertension, but also just plain old hypertension. They are reflected in low birth weights. There's 2 types of cancers that are positively associated, though there's a paper out yesterday that said thyroid cancer is a 3rd, and it's a revisit of the data. And here's a killer, the immune suppression. These are immunotoxins, and all of them appear to be, that they will reduce the vaccine effectiveness for anybody who has a higher blood level of these than lower. And it's pretty striking. There was a Faroe Island study on children, and when they looked at the titer a year after the standard 4-year-old or 4th grade vaccine, the students with very low levels of PFAS, but some of them were higher than others, the students with twice as high had half the vaccine response, which is scary. And this is the number of publications per year in the reverse order, I'm afraid. But from 1998 up to 2022, last year there were 1,400 publications on adverse health, and it may not be human health, but also animal studies. But this is adverse health and PFAS studies that are published. I can't read 1,400 papers a year. I mean, it's just overwhelming the number of studies that are coming out. Yet, as little as 20 years ago, there were single digits or dozens of these papers at max. So I think that this is a recognized, become important, but this was, remember, the first ones were invented in the 1940s. So it took a long time for us to notice. There are some public perceptions that are out there. A movie, Dark Waters, that came out just around COVID, but it was an occurrence of a study of this C8 study, a movie about the C8 study that was performed in the early 2000s, and definitively found 6 adverse health outcomes out of the 31 they looked for, and did a study, epigenetic, but also a toxicology study of 69,000 participants. Really a very large study to show that initial data. So the question is, now that we know this class of chemicals is persistent, bioaccumulative, and, oh, by the way, toxic, the NIEHS has published a bunch of studies on showing how toxic it is. Some of the chemicals can reach sub-part per trillion levels in drinking water and still be recognized toxic effects. There's so many that we haven't done toxicity on all of them, but the ones we've looked at have all had varying degrees of toxicity. They are all persistent, and several of them are bioaccumulative, not all. But we're given more than 12,000, how do you get rid of them? And in fact, how do you measure them? And the standard way is a chain. I mean, get a volunteer graduate student to a LC mass spec shown there, which is a chemical instrumentation that will be very sophisticated. You put internally mass labeled reference standards in, you spend hours of your day slaving over the instrument, and you can get calibration curves that are beautiful and get detection limits nowadays down to about 1 part per trillion in an academic lab. If you really try hard, you can get lower than that, but it's a nightmare down there. Because at that point, you not only have to have good laboratory practices, you have to have paranoid laboratory practices not to get cross-contamination. I mean, PFAS are in drinking water and in rainwater. I mean, it's the only thing you have to do is distilled water to get the PFAS out. But then these instruments get delivered with Teflon parts, and you have to strip all those out of the instrument before you can get the background low enough to be able to use them. So it's excellent. It's the gold standard for measuring them. It has excellent sensitivity. You always get a % recovery out of them from last label standards. It's very time consuming. It takes about half an hour to an hour for a sample. And that's not including the prep time, which is often several hours of extracting, digesting, and cleaning up, and then boiling it off, and then getting concentrated enough that we can see it in this. And it has a significant fault in that it only identifies what we have standards for. And we don't have standards for 12,000 PFAS. We have standards routinely for drinking water about 27 to 50. And if you are a real extremophile and you have every standard known to man, you'll be up in the 50s or 70s. Very few people run that many through. And so what about the other 12,000 that are out there? You don't measure them. And that's going to be an issue, we discovered. So what my research group does is say, well, we had this question posed. What if you could develop a rapid screen? And the example there is shown by the handheld X-ray fluorimeter, where we're looking at the rubber ducks to see if there's cadmium on that yellow paint from China. And I like that photo. It's a quick way of scanning and measuring X-ray and saying, wow, I see that particular element visible. It doesn't mean it's cadmium paint, but if you see a big cadmium line, it could be. It most likely is. So anything to do with spectroscopy is you shine light on a sample and measure it, or the absorbance, or you excite the sample and create light and use that interaction of light with matter to detect it. And fluorine is present in all these chemicals, but unfortunately, fluorine doesn't have a UV-Vis transition, and none of the transitions are in the visible UV range. It does have an FTIR signature and an NMR signature, but unfortunately, those are typically in the % level. You need to have % concentrations to be able to measure those. And the NMR is, takes hours per probe. The XRF will give you a nice X-ray line from that, but it is, unfortunately, it's too low to be detected. It's going to be a light element, so it isn't detectable by XRF. So we have turned to gamma ray spectroscopy, and that's where our device comes in. This is a small accelerator I have downstairs. It's used for applied physics, and this is applied physics. I'm taking a well-known technique for 30 years, and I'm bombarding it onto a target. You'll see a target wheel here, if you can see my pointer, where we put targets in air. So the only thing we did differently is we brought this ex-vacuo. We put a membrane barrier, and bring the beam into air. And the proton, as it interacts with the fluorine-19, gives a very specific background, and that the 110 and the 197 keV are lines that you can use to identify absolutely that it was fluorine-19, the only isotope of fluorine that's stable. And so what could you do with this? Well, you start measuring things, and it's a student-driven project. Often the students bring in something and say, hey, I've got this food wrapper. Can we see if Jimmy John's has got PFAS on it? And the answer is, we published a paper back in 2017 with 400 and some papers that we studied on all the major fast food wrappers, and we found fluorinated chemicals in about 35% of them. And that went viral. There were lots of news stories about it. There was because people are very concerned about what they eat. And that was sort of an education for a scientist to publish. I've written lots of papers. Very few of them had more than a handful of people read them. Here's one that 45,000 people have downloaded, and there were news stories about it, and they came and interviewed me about this. And they missed the point. The point was that, at least in my household, nothing stayed in the wrapper for more than 30 milliseconds. I had teenagers. They ate the hamburger, they ate the taco, they ate the chicken, whatever it happened to be, or the pastry. But the wrappers in this country, 100% of them go to the landfill. If they're in the landfill, a good aerobic landfill will decay paper in about 60 days, paperboard a little longer. That means that 100% of the PFAS that were on that container to keep it waterproof or greaseproof, for convenience, you don't want to get stains on your lap when you're eating in the car. For that convenience, you are getting 100% of those chemicals in the leachate water of your landfill. And that comes through because nothing really takes it out. And then it gets into the irrigation water you apply to your crops that you eat or that you drink directly. And so that was the main point of the paper, but everybody said, oh my God, I'll never eat another wrapper in my life. There was an Onion article on this. It was quite a good satire. But it was one of those things that if we had our druthers, would you put them on food packaging? Is there an alternative that's better? And in fact, the good story of this was that there was a sitting US Senator, Senator Durbin at the time, who wrote a letter to all 20 companies we had identified, all brand names of Panera and McDonald's and all those, and said, we understand from the Washington Post you have this in your packaging. What's your company policy for removing it, and how soon will it be done? And when you get a letter from the sitting U.S. Senator, every single one of these 20 companies called in somebody and said, make it go away. We sell chicken, we sell tacos, we sell hamburgers. We don't sell this poison, so just switch. And you know, the packaging industry changes every 3 months anyway. This is what, pumpkin latte season or something like that, going on to Christmas season. So the papers just changed, and in 18 months the entire industry, at least for these 20 companies, switched away from this perfluorinated paper. They said, we don't need it, we avoid the litigation. So it was litigation avoidance. It happened in 18 months, and the first law that passed in this country was in state of Rhode Island and in state of Washington. And now California and New York have got the laws on no PFAS in paper, but those are 4 to 5 years after the publication, whereas the companies, the ones that were identified, the large ones, already had started switching away very quickly. And so that was a case of a paper influencing policy, with a very neat result, is that here's a place where it wasn't necessary. There's a easily readily available alternative, and most of the papers, they just use a polyethylene lining. So we're making more plastic, but in fact, it's probably much safer for what we're getting into the environment. Another story I've been asked to describe was, after that, we got contacted by the firefighters. And this photo will ring true to many of you in Madison. It's a picture of a transformer fire that occurred in Madison, I think in the summer or the late summer of 2019, just before COVID. There was a huge transformer fire from a lightning strike, I believe, or several of them. And the fire department was called to put it out, and they did with it's a dangerous chemical and a dangerous environment. They put it out quickly with a aqueous film forming foam. AFFF is a fire speak for their foam to be put onto combustible materials. And these things are filled with combustible materials. And so everybody knows that the AFFF was made with PFAS up until last year. And so what we didn't know was that the fluorochemicals were dangerous, and the fire services were never told that, of course. It was safe as soap by the manufacturer. So the U.S. Navy had been using it for 50 years, and the metropolitan fire departments do when they hit a petroleum fire or a tanker truck fire, or in this case, a transformer fire. And so the fire department did a marvelous job. Nobody was injured. They put it out in a record time of N hours. They had to fight it for, I think, several shifts. It was a 3-alarm fire or something like that. A lot of departments responded, and they were all happy that they got it out. But then there's this unfortunate runoff of this foam that was loose on the ground that goes into the nearby lake Monona, I think it's called. And there was, of course, then a lot of paperwork to fill out because the lake had been poisoned by PFAS. And that was an embarrassment that's been repeated across the country a dozen times. Just the first time that people are aware that the use of firefighting foam has actually a tremendous impact on our drinking water. That initial map I showed you was probably due largely to military use of firefighting foams, but there are also some municipal use of firefighting foams as well. And after this story came out, people, the U.S. Navy, due to a National Defense Authorization Act of 2022, 2021, I think, have banned the use of AFFF, and they've switched to fluorine-free foams, which are indeed PFAS-free. But I got a note from the woman shown here on the right with her husband, Paul, Diane Cotter, who wrote and said her husband was an active firefighter who had been serving for 22 years in the fire services in Worcester, Mass., went up for his lieutenant's exam, and the day he got the results, he passed. He's now a lieutenant in the fire services. He came down with a cancer, and it took him out. He's alive, but he's on disability. He cannot work any longer. And so that cut short his career at a stage of his life that he was really looking forward to. And quite frankly, his wife was angry, said, how can this happen? How can 4 guys on the truck have the cancer at the same time? There's only 12 people assigned to a truck. And she thought that this personal protective equipment, the bunker gear or the turnout gear, they call it, of the things with the stripes on it, is a special fabric to keep them safe in fires. And every firefighter has a set or 2 probably. And it's very expensive, but it's cheap compared to the life of a firefighter, as an advertisement there says. But she was concerned that these things might have PFAS. In fact, they might be made from PFAS. So she sent us some samples after nobody else would listen to her, and indeed they did. So we published a paper in 2020 that said there was another pathway, not just AFFF, but you could get, these things were percent levels of fluorine in them. And then when we did extractions, we found that there was a lot of PFAS in the gear, and they could migrate to the skin. We don't know the dermal absorption of PFAS. Nobody's measured that yet. There's a paper on en route coming out. There's been one study published and another one about to come out. After an initial study back in 2010 that said there wasn't much, but they didn't look under every condition. Under normal conditions, we can see transmission of this through the dermis. That's not good. But more importantly, we found it also in the station dust. There's a picture of my students wearing nitrile gloves because after they handled the gear for a couple of hours, or even a couple of minutes, we could see transfer of fluorine from the gear onto a nitrile glove. We put the blank glove in the beam, and we could see fluorine on it at the parts per million level. So we know it's coming off. It's what's called a side chain fluoropolymer of a methacrylate, and so the fluoropolymer doesn't break, but its connection point to the textile does, and therefore these little fluorochemicals are let loose, and they can decay back into PFOA or PFHXA, and they did. And so when we look in this 15 fire stations around Boston, we found a whole bunch of PFAS, and they were all in the living room or the gear locker room, but not where the AFFF was stored. And the AFFF looked a little bit different, but most of the concentration was in the living areas. So these firefighters are exposed to the dust or inhalation from their gear while they're wearing it. And nobody told the firefighters ever that this was potentially a dangerous chemical. And so they were all told, yeah, it's safe. We don't use PFAS. At first they were told, and then they said, well, we do, but it's a safe kind. Well, there is no such thing as a safe kind. And while it doesn't come off, well, it does. And so these went on, and there was a follow-up study that Jennifer Field did with me on to not only measure that the original results were correct, but also she measured the volatiles, which I couldn't do. And that led to this. It was a IAFF-funded study this time, and it suggests that there's not only the gear have PFAS, but they come off and it's bioavailable. But here's the graph from the second one, which showed the volatiles at factors of 10 higher sometimes, or sometimes even 50 times higher than the non-volatile volatiles, if you use the GC mass spec to measure them. So this was where we said, it's even worse than we thought. There's not that firefighters would ever be in an environment that was warm, but that led to another source of exposure. Do we know that this is getting into firefighters' blood? We don't. We don't have the blood studies. The epidemiology study is going to take forever to do. It's just a potential source. My best dream is to wake up one morning and find out that it isn't the effect. It's all AFFF. But my worst nightmare is to wake up and say, wow, this is a problem and we didn't catch it soon enough. because there's 1.2 million firefighters out there, and if you don't know, they suffer cancer rates at roughly twice what the average population does. Now, of course, they're exposed to carcinogenic smoke and other things occupationally, but what if their PPE is actually contributing as well, especially to some of those cancers that we know they suffer so much from, like multiple myeloma, leukemia, and things like that. There's not strong correlations with those in PFAS yet, but it doesn't mean it isn't a contributor. We look at peoples with suppressed immune systems. This is such an insidious chemical. It suppresses the immune system. So if you look at transplant patients that have a naturally artificially suppressed immune system, the most common diseases, the most common cancers they get on an organ transplant would be multiple myeloma and leukemia. And those are the top two in the firefighters as well. Is it because they have a suppressed immune system? Could that be due to their PFAS exposure, which is not a direct linkage to which particular PFAS it is? That's just some of the suggestive data. We have no confirmed proof on that, but it's just scary. The third one is kidney cancer, which is related to kidney cancer and testicular cancer, these big vascular cancers that are shown to be directly related to the long chain PFAS, the C8s. But anyway, what does this mean? This is where I've spent a lot of time talking to firefighter conferences saying, yes, PFAS are used in turnout gear, mostly to provide water resistance to the gear. PFOA is one of the things that was used prior to 2012, actually probably prior to 2015. And it's also a degradation product from some of the other fluoropolymers that are made up this thing. And they're typically in the 10 to 100 part per billion, which are still trace amounts, but way higher than the water limits. You wouldn't eat your gear, you wouldn't drink your gear, but that shedding of dust or inhalation of those sort of things are ones that constitute a potential exposure source. So the answer is you still have to wear your gear. Don't go into a fire without it. It's designed to keep you safe. And this gear shouldn't be worn when you're not actively in a fire. You should keep it in a bunker locker, and you should vacuum the bunker locker out. Those sort of operational practices are in place already. And more importantly, every single one of the 4 major manufacturers of turnout gear has now switched to a PFAS-free alternative. All you need to do is keep it waterproof. That's what it's there for. And there are lots of chemicals that can make things waterproof. PFAS is the best of them, but reasonably dry is just as good when you're talking about exposing that. And it's taken in a remarkably short period of time, because the firefighters are so connected on social media, to get this blazing through the fire services. And the fire services, they use this AFFF. They know that's a concern, but that didn't worry them. When they thought it was on their gear, the ones that they take pictures of their family and their own gear, and they say, would I do that if I knew that it was a cancer-causing chemical in there? Nobody told me. And that's, I feel for them. I mean, they were lied to by a company that made the chemical. And now the companies are none of the companies have gone out of business. They just switched to a type of gear that's fluorine free. And the company that did it first got a little bit of market edge, because they said, I wonder if we have a plan B if this study is right. And we told them all about the study before we did it, and we told them what we were finding. And some of the companies adapted quickly and came up with alternatives, which is good news. I mean, there is an alternative. We just don't need PFAS in this particular place. Even though it's essential to keep firefighters dry, that's just not one of them. And that led to a whole series of other papers that I won't spend a lot of time on, but these things like cosmetics. This went absolutely viral. If you think people are concerned about what they eat, people are really concerned about what makeup they wear. I cannot believe the number of people that wrote to me about this. And again, we did a study of, I think, 230 so cosmetics, and out of the 200,000 that are available. And we found that there were categories of cosmetics that hadn't been studied widely before that were very high in PFAS. For example, waterproof mascara, and the liquid lipstick, the paint-on lipsticks that the younger generation are using. None of those, the lipsticks that are in a stick, but these are actually paint-on liquid lips, they call them, or somebody calls them that. And those were found out in some cases to be about 90% of them were treated or had PFAS on them. And if you think about bad places to put them, doing them on an ingestion path on the lips or on near the tear ducts with the mascara, it didn't seem like a good place to be using PFAS. Even though it's essential not to look like a raccoon when you come out of the swimming pool, I understand that. But there are at least 10% that don't use it. Couldn't we go with a slightly less waterproof mascara? And again, the direct path exposure is one of concern, which will scare many users. But reality is mascaras never get used up in the bottle. They always leave the lid off one night, and then you've got powder. And so the bottle gets thrown out, and they're designed to buy a new bottle quicker so that I'm sure it's part of the design of selling these things. And most of the mascara will either wash off or end up in the garbage, going through in this indirect path where even if you don't wear any mascara, you are still drinking somebody else's mascara because the PFAS off it will come out in the drinking water. And so that was the main point of the article. It had a huge ripple effect in the industry. They're very sensitive to Prop 65 chemicals. Two of the PFAS are in that list, and soon to be a third and a fourth. That means that the companies, even as large as the big ones, the Revlon and the L'Oreal's, both announced in Paris last year that they were removing PFAS from the 80,000 products that they sell each. And so that means that it can be done. All they have to do is clean their supply chains up and say, we don't use that chemical. But it's costly, but it is relatively minor compared to the potential of human health effects, I would believe. And those are good news. We've done other things, school uniforms. We don't wear them much in this country, but Britain does, Australia. But in Canada, we had some Canadian ones, had a lot of schools. And in the US, it's relative to Catholic schools, I think. But we found them in a good fraction of school uniforms. Is there anybody else you can think of that wears a uniform? Yeah, that gives you a lot of pause, right? Because you've got armed services, you've got your local prime drivers or your UPS drivers, or you've got your people that work at fast food stores that are not only handing out papers, but they're also dressed in uniforms. Hospitality has a uniform. Everybody checks you in with a uniform. I mean, all these people, flight attendants, don't even get me started on flight attendants. Those guys have flame retardants and PFAS and antimicrobials out of the uniforms. And there are lawsuits developing on that. I think that people are pretty unaware of what goes into an unregulated industry. The textile industry is completely unregulated. You can make underwear out of asbestos this year if you wanted to. There's nothing stopping you in this country from making underwear out of asbestos. The only people that's stopping you are those late night lawyers, the mesothelioma lawyers, say if there's asbestos you've been exposed to, contact us and we'll sue them for you. And so that's what's doing it. It's the U.S. doesn't regulate so much as it litigates, which is kind of a strange way to do it, but it is very rapid. People will shy away from this if there's a threat of a lawsuit. And most importantly, the manufacturer will say, do I do the toxic chemical or do I make the uniform? You know, in the old days, you didn't have stain-proof uniforms. When I was a school kid in a uniform. When I grew up, I got my uniform dirty. Public schools in Australia had uniforms. My mother had this invention called a washing machine, and she washed it. Nowadays, it's it's wrinkle-free and it's water stain resistant. But if little Johnny is going to be coated with PFAS by wearing it, is that really the best place for it? Or more importantly, when it goes in the landfill, we're all going to drink it. So we did that. We do other research as well. We do research with collaborators in these areas of biology, for example. So we reported last year the first observation of maternal offloading of fish eggs. So yes, it's in all the Great Lakes fish, but we found a difference in spawning females versus males. The spawning females had lower levels of PFAS in the tissue, and that was because the eggs were absolutely loaded. You can see that the overall eggs were higher than both the female and male, and you see sort of the decrease in the female after spawning of the eggs. Good news is not many of us eat salmon egg as roe, but other creatures do, and so that's a rich protein source, and so all the other creatures eat the fish eggs. That's why they spawn so many of them, and that means transfers the PFAS inland, and often these critters are on agricultural fields and things like that, so it spreads. So what is the role of a fast and rapid technique? And here I show another graduate student chain to volunteering at the accelerator. And they run these instruments and survey lots of materials, and then they develop new methods to go better and further. The role of this sort of total fluorine method we've developed is that we can do a lot of where is it and where is it going without having to identify which one it is. We can see anything with fluorine. It's unambiguous. At our accelerator, we ran about 5,500 samples last year, each under 3 minutes, and which is pretty good speed for these types of analyses. It does require an accelerator, and it does quantify only total fluorine. We have to use some chemistry to distinguish between inorganic and organic fluorine. But if you look at paper and textiles, there is no inorganic fluoride there. And so Yukon, who was on that previous slide, has developed this technique now where we believe we can use this wonderful thing down here called a GAC felt. graphitized activated charcoal felt. It looks like flannel, but it's made out of sintered carbonaceous nylon, for example, and it's burned in the absence of oxygen to make this felt that's used in commercial filters that are put in buildings to try and clean the air from organic smells. And what we use it for is to pass water through it. We take a known volume of water, drip it through with only gravity, and then we put these on our wheel of targets to analyze, and we can get a quite linear response from a calibration curve. We increase it. We publish this method, and it turns out that by increasing the volume, I can get to lower and lower detection limits. So for 2 liters, I can get down somewhere close to 20 nanograms per liter, which is, I guess that's a 4-liter sample, 3.5. A gallon gets me about 20 nanograms per liter, which I thought was pretty good last year until the EPA lowered its regulation limit now to 4. So we have to do, again, more volume. So we'll run it for longer to get that. But the idea was, and we spun off this company this year, Forever Analytical Services, is an idea of a home test, but also one where regulators can look at large number of samples in a very short period of time, just distinguishing which ones need to have the furthest signal. The ones with fluorine signal get sent off for further analysis to see which chemicals are there. But if we hope that 9 out of 10 or 6 out of 9 here samples have no fluorine, you don't have to send them for the expensive LC mass spec test, because if there's no fluorine, there's no PFAS. So that's our development of analytical methodology. But when we started doing this, we started beta testing on all these waters around the country, and we found that the R values in red were always higher than the values in green, with except of this one Air Force base in Alaska. All the rest were, quite a bit higher, factors of 16 or 17 or 20 times higher than what you see with the LC mass spec. And people worried that, where are you getting all that fluorine from? That can't be real. Maybe it's fluoride, but we don't fluoridate water naturally, so it's unusual that it would be that high. We had seen that before because of paper back in 2017. When we did Piggy, we got about 98% of the fluorine out, and there was about 1% measured by LC mass spec. There was suggestion that there's a lot more fluorine there, but we didn't know where it was until this paper from last year. And this is a game changer for everyone, guys. This is one where they identified novel ultra-short PFAS. So PFAS are generally, in this country, assigned as C2 and above. C2 carbons or 3 carbons or 4 carbons up to 8, 9, 10, 12, 14. And you can go quite large on these things, but they're all PFAS if they have this alkyl chain on them. But if they've only got 2 carbons, then it's a C2 or a C3 here. And this is a weird one. This is the counter ion in your cell phone. When you have a lithium ion battery, this is what goes in with the lithium, and it's a fluorochemical. Oops. Okay, so the cell phone battery fires aren't really good either. And what they looked for in 13 different drinking water systems in Germany is that they measured these things for the first time, and they found that 98% of them were TFA, the C3s, C3s, which are short chains, which are not measured by LC mass spec. They had used different techniques. And 2% was all the stuff that the LC mass spec analyzes. So what we're regulating in the water chemistry in this country, for example, and Europe, they're looking at LC mass spec as the tool, but it doesn't have these in the library. They're too short to be measured by typical LC mass spec methods. You have to change the method to see them. And so we're all rapidly changing the method, but that means all our regulations are based on 2% of the fluorine that's there. And this leads to, for public health, everywhere we've looked, I'll show what the results are. We have redesigned our method now to go with a cap. Good, I'm running out of time, but I'll do this quickly. We have a cap that is a $1 bag that we put a cap on with a hole in it. We put this in, anybody can tip the bag upside down, and here's our graduate student collecting samples in a hotel room and draining them out in the bathtub. And what you're getting is a very rapid screening technique. And in addition, we've discovered how to remove the C2s and C3s. We have some sensitivity towards it. And that's what we're seeing in all our big red bars that are over reporting PFAS. It's really there. It's just that we had the measurement to see it, and the LC mass spec didn't. And so now we want to know how to get rid of it so we don't see it, because people only want to regulate the seen ones. But I think it's very important to have both. We have a total fluorine measurement, and then we have a total fluorine without the shorts on it. So we managed to remove it. That's what these plots are showing. But even at low extraction efficiency, these ultra-short PFAS make a significant contribution to the signal we see. And that's why it's important to be able to understand what that is. So going forward, what we're going to do is send the caps out. People put them on bags and filter them. we send them back and analyze them, and we can wash the inorganic fluoride and ultrashorts off just by a simple nitric acid wash, and then we run the samples after they dry. So it's very easy to do. It's going to be cheap. And when we do this in northern Indiana, the grad student basically drove to all these places. We found that the part per trillion in PFAS looked very much like this, where the limit of 0 is good. That's where you'd like it to be. These ones are all measurable, but most of those are going to be short chain. Those are going to be C2s and C3s. This one is actually a contaminated site, and we've independently verified that now. So using this technique, finding the contaminated site was easy. But even these other ones, which the state says are uncontaminated, we can see PFAS there, but it's a short chain stuff. What does that mean for human health? Well, companies have immediately sprung up and said that's safe. These things don't live in the body more than a few weeks. It's got to be safe. The PFAS themselves are known to have, the C8s are known to have 4- and 5-year half-lives in blood, red blood cells. Red blood cells die in 60 days, right? So these things are living in organs and circulating after an initial exposure for over 5 years for a half-life. So these things that wash out in a week or two, that's got to be, at least 50 times safer, right? And that's what the companies have claimed. But if I think of another drug that you take and that washes out in a day, that would be alcohol. I mean, I can't tell if any of you drank last night because the blood today won't have alcohol. It's all metabolized. While these things don't metabolize, the C3s will wash out, I'm sure. And so you'll urinate those away. But what if you have exposure every time you take a drink of water or beer or wine, because beer or wine don't get rid of it. It'll be in there. Sorry to tell you. Unless you drink reverse osmosis water, you cannot get away from these C2s and C3s as far as I can tell. And that means that we're all drinking it every day, and it's a cofactor in terms of everything else that you ingest. A lot of studies need to be done on that still, and they're still forthcoming. It'll take a few years till we get more studies on this, but it doesn't bode well for these PFAS in general. So here's my conclusions. Take-home messages. There are a lot of PFAS out there that are not being measured. The ultra shorts is the latest thing that just broke last year. And boy, we're all trying, all the groups I know are trying to measure them and be able to characterize them. We got lucky, we can catch them with our technique. And so we do see they're there. We can't quantify them very well without a better technique. Total organofluorine measurements can be used to screen for PFAS, and I think that's an essential step. Coming with a cheap screening tool before you do the expensive LC mass spec is going to help revolutionize what we do. And here's for the audience, there are many products that contain unnecessary PFAS and multiple pathways for these products to get into you and I. And I think that's the scary part. I'm not invited back to many parties, as you can tell. There's a role for this technique to be complementary. I'm not trying to replace LC mass spec, but I'm going to do it complementary. So if I have 100 samples, hopefully 90 of them are free. I don't have to send them out for analysis, at least not very often. And what do you do when facing a global persistent pollutant? The argument there is, as scientists and as practitioners, the best thing you can do is educate yourself, and then all the others will listen to you. I mean, it is possible in this country to use market forces to drive companies away from it. And it is fear of regulation. Europe regulates, America litigates. And so if you find something and you put a spotlight on it, peer-reviewed study that says, hey, we found it in 30% of the papers, suddenly the paper industry responds and they move away from it because it's easier to do than to try and prove it's safe, because it isn't. And I think that is being repeated. I've got about 200 papers left to publish now because there's 200 different industries that are using this stuff. We're going one by one, starting with the biggest ones we could find now, and sort of saying, hey, it's there, it's available in turf grass, it's available on your watch bands. You guys got Apple Watches any chance? Oops. Okay, all sorts of things like that. We submitted that paper today. And so we're going after these these consumer products because we think we can drive society away from using them once you see the risk benefit. I mean, you should be able to get the similar performance without the use of fluorine. And the only ones that lose are, unfortunately, the fluorine making companies, and there's only 2 of them. So I'm not too worried about that. And that's the talk. That's the group that did all the work. I just talk about it. I do have my email address there, but I'll be happy to answer questions now if there's a forum for doing that. And the funders that provided a lot of this. We're heavily funded. We're producing a small accelerator in a truck, so it's mobile and portable, and that's what we're doing with the Department of Defense. And that'll have practical applications for making this technology more available. I'll stop there and allow you questions as best we can get them. Can somebody say or type? Oh, I see a chat. I should read the chat, shouldn't I?
Hello, Graham, can you
Yep,
hear me?
I can.
So thank you very much. That talk was awesome. Uh, Hopefully we haven't depressed everybody in the room though, right?
I'm not
I do
invited back
have-
to parties, you can tell, but
Yeah,
it is important to get the message out. And I
yeah,
think
I do
it's
have my Apple
empowering to
one.
know to do something about it. I mean, you
Yeah,
guys can report, you guys can and follow up, and you'll understand a lot more of the health than I do. And I think it's important to say, for example, there was a published study last month that said PFAS was in drinking straws. And we've measured them for years. I've never seen one in a drinking straw. So I was really surprised until I looked at the study and they were measuring part per billion amounts in the straw. And that's just way below any level that'll have any functional effect of waterproofness. So it's not being added intentionally. That's just recycled paper content in the paper that we use. All paper is recycled in this country now. And so that's what you're seeing. And PFAS is everywhere, so you're seeing low amounts of it. But the industry, of course, got hold of this and said, oh, we want to keep plastic straws then. Oops, wrong answer. You don't want plastic straws; those are a nightmare. You want to go to paper or reusable products. But what we want to do is get the recycled content down, so we stop using PFAS. Sorry, that was my take on you, and not a question. Should we answer questions?
I have a few questions that have showed up in the room here and on the chat.
Yep.
One is related to, okay, hang on a second. Let me just look these over.
I'll let you read it to me because then I don't have to.
Okay, all right.
Okay.
So you mentioned this issue of the short chains and the ultra short
Yep.
chains. So if someone wants to get a water filter for their house, what would you recommend? Because some of the data says that the ultra short chains can sneak through some of the filtering systems,
Yeah, every filtering system it'll sneak through. We haven't found one
even
that'll.
reverse osmosis.
Reverse osmosis is not a filtering system. Yeah, that one is true. Reverse osmosis will get rid of ultra shorts and everything. That does work. But
Okay.
any of the Brita filters and things like that, they work very well for most PFAS, but they will not work on the ultra shorts. But then again, unless it's just distilled water or reverse osmosis water, which is very expensive, you're not going to have that in a home filter typically.
Okay. Another question. You were talking about the firefighting foam that went into Lake Monona,
Yes.
caused high levels there. Therefore, we're going to have fish with high levels
That's
in Lake
correct.
Monona. Do you think there should be a sign up there that said pregnant women and children should not drink fish from this waterway?
That's a very good question. Whether there should be a sign or a regulation, there are some regulations in the Great Lakes fish, but not on Lake Monona, of course. And so I believe that Lake Monona is used for fishing widely. I know that people catch fish out of it. I suspect that it's not equitable. Some people eat more fish out of it than others. And so therefore, I think it is a concern. The one chemical that bioaccumulates the most is PFAS, and that is a primary ingredient in firefighting foam. And I know that the Madison Fire Department did a marvelous job. They led the state in switching to fluorine-free foam because they didn't want that to happen again.
Okay.
There was a Chief Davis there at the time who did a really nice job of doing that publicly and took accountability and just marched in the right direction. And that was really remarkable, but I don't know what Wisconsin DNR did with the lake. They probably are monitoring fish there, and it will take a while to get into the fish. And the small panfish don't live as long. They may not have gotten as much, But I don't know. I haven't seen the fish results, but in principle, yes, they should be contaminated.
Okay. You talked about the absorption through the skin, which if you read a lot of the data, that's not considered a big source. So should we be worried if we're wearing products that have Gore-Tex in it and things like that?
I think the biggest product, and I've tried to say this again, the biggest concern with wearing the Gore-Tex and the rain suits and all that sort of stuff is probably not dermal or dust absorption, ingestion, or accidental inhalation. I think the biggest problem is when it goes to the landfill, we're all drinking it. But that said, there was one study from 2012 that said that not much dermal absorption, but it was an incomplete study. Even though done by a good group, it was not, they even admitted in the study, it's an incomplete study. There was an N=1 study done last year and published that showed a significant fraction of PFOA went through the skin. And there's a study on its way out. I happen to know it's on its way that measures the absorptivity of about 12 of these things or 20 of these things. And they all go through the skin. The short chain ones go through faster, the long chain ones go through slower, but all go through. It's not zero. It's not, instant. It takes, interestingly enough, some of them stick in the skin and some of them don't go all the way through. They absorb the skin, but it was possible to see sort of percent levels into the blood. And that one's going to be published soon. And so that will be out. And I'm sure there's 2 or 3 other people. I know of 2 or 3 other people working on it. It's a very difficult study to do. And so I would not discount dermal absorption as a route. I don't think that an occasional wearing of a Gore-Tex coat is going to do that. But when you manufacture it and make PFAS, or when you throw it away at the end of its use, then those PFAS. So it's a lifestyle choice, right? I got rid of my Teflon pans, not because they're going to kill me so directly, but because I don't want, I can cook just as well on ceramic, it turns out, which is not very well, but I can cook at least. And it works just as fine as Teflon. And so those sort of lifestyle choices, if you have a waterproof parka that you can go up Mount Everest with, yeah, you're probably on a good waterproofing agent. If you're going to the mall, does it need to be that waterproof? I mean, really. And so that's the type of decision we're trying to make here. Where is it essential use? And I've found very few essential uses of PFAS. Firefighting foams might be, except for the fact that they found an alternative that works. Heathrow's been on fluorine-free foam for 4 years now, and they've had several plane fires, and they work just fine. But so I think that there are arguments that almost all the uses we have for PFAS at the moment are non-essential. They're convenient, certainly, but not necessarily essential. And so the microwave popcorn is a great story. In 2015, the Danish banned it and pulled it from the shelves on its major supermarket shelf. Within 6 months, there was a replacement that was made out of paper. A U.S. company came up with an innovation to make the paper thicker, then it didn't need fluorine. And to this day, that hasn't occurred in the United States. We're still eating popcorn with microwave popcorn with PFAS on it. And so if you have some at home, don't throw it away. You can take the popcorn out and cook it the normal way. Just throw the bags out and let us all drink it.
Okay, I have just a few last questions. I have a lot of questions. I just can't get through all of them, but
if you don't get your question asked, just send an email. I'll be happy to respond.
Okay, great. One is, what are your comments on breastfeeding?
Yeah. Everything we've looked at suggests that the breastfeeding is it passes right through. Even worse, in gestation, we see in a mouse model, we've stuck PFAS into a mouse, a pregnant mouse, and we observe transport through the placenta right to the fetus at a faster rate than glucose. We readily label glucose. We readily label the fluorine 18 is a great label, and we readily label some PFAS, and it was transported. And so you got this, fluorine 18 is a PET emitter. So you have this PET image of 18 little blobs of there were 18 fetuses, and there's one mouse, and you see all these little Christmas tree lights, which is the PFAS going preferentially to the fetus. And so this is a really tricky substance, and of course the studies are incomplete, but I would say that breastfeeding is of concern. We have seen on a lot of the other longer chain chemicals, the polychlorinated biphenyls in the mammals in the Gulf of Mexico. You see that the first child of the dolphin died, the second one lived, and the mother's PCB levels went down after birthing and feeding. And so the first child dies, the second one lives, and that was an alarming reason why the bottlenose dolphin population was decreasing. PFAS isn't quite that extreme, but I would be willing to bet that the mother's level of PFAS will translate to breast milk, and there are a couple of studies that show that.
For the companies that are taking the PFAS out, what are they using as their replacement? Is that equally harmful?
Excellent question. It would be terrible to be using asbestos, right? No, they are generally using silicones in most of the applications, and silicones, while not perfect, are certainly safer in terms of their long-term and biological effects, but there are obviously some concerns with them. I don't know if there's a perfectly safe chemical out there for everything. It's more or less a one-by-one treatment. And what I have seen is that the ease with which the company can switch from, well, the P4 and PFAS are the C8 versions. We're switching to C6, and that's safe. Absolutely not. That's a regrettable substitution. The C6, you have to put more on to make it have the same property. It's more soluble. And there's some evidence from our radiological studies that it goes preferentially to the brain instead of the kidney or the liver. I don't want any more of this stuff in a different organ. I just want not to have it. And so I think that the switch to an alternative has to be always looked at carefully, and it's not something you can do without thinking about it. But there are almost every situation there are alternatives still. There's a couple which there aren't.
Okay, this is our last question. So because we have a room full of physicians here also, is there any value in doing universal blood testing for PFAS, or how do you feel about blood testing?
There is, and there is, I'll announce Eurofins USA has come out with a test, which is a not a venous stick, but a capillary a pinprick. And that's lower cost. It's like $300 versus $800. But you don't need a phlebotomist. You don't need to do the vial, all that sort of stuff. And the trick is they're getting much better at the reports. They're making the reports only 36 pages long instead of 100. And so you can actually start to make some sense of it compared to NHANES data. And I think it's very important to start, if not everybody, especially people that are concerned with their, a widespread monitoring would be great. We've started in Indiana the first monitoring of firefighter blood, only 1,000 firefighters a year, but they're going to make their blood as part of the general physical. And they'll use it to look for warnings. If the PFAS is elevated, you look for the methylation markers, things that are signs of cancer or some other hypertension and things like that. You can monitor that before it becomes, the cost saving measure is a stage 4 cancer is much more expensive than a stage 1 or 2. So if you can get some warning that you might have been exposed, therefore you should be watching out for these cancer signs. That's the argument. And I think it's a strong one. And that for universal healthcare, the real argument is that we have too few physicians that understand what in the heck the PFAS is. These guys are overworked and understaffed, and nobody's got time to read about this stuff. And so how do we know where to go if we have PFAS questions? And there are a couple of states now forming boards of physicians that can do that, but there's 47 states that have yet to. And I think that's going to be a real key area of growth for the medical industry.
Great. Thank you so much. And I'm sorry we couldn't get to all your questions, but
I'm sorry I can't be there to answer in person afterwards, but I'll be happy to answer online. Thank you, guys.
thank you so much.
All right. Thank you so much again, Graham. I'm going to pass the mic to Dr. Henry Anderson, who's going to introduce our next speaker.
Thanks a lot. Our next speaker is Dr. Ed Maibach, who is Distinguished University Professor and Director of the Center for Climate Change Communication at George Mason University. I think some of the questions that came up in the first session, hopefully we'll get some direction as to how best to communicate to the public as well as to the professional community. He's a fellow of the American Academy for Advancement of Science, member of the National Academy of Medicine, and he serves on the board of directors of the Global Climate and Health Alliance. He previously served as associate director of the National Cancer Institute. Since 2007, he has focused exclusively on climate change as the world's most pressing threat to public health and well-being. His research, funded by the National Science Foundation, NASA, and private foundations, is centered on public understanding and engagement in climate change. With Dr. Leiserowitz at Yale, he co-directs the Climate Change in the American Mind polling project. This is a research program that's currently in its 12th year. And for those of you in the research community, keeping a grant going for that length of time is a real achievement. So he's had this, and if you have a chance, read some of the publications. The insights that he's had from climate change in the American Mind polls that are run by this program led him to explore and develop various avenues to enhance public understanding and engagement in climate change. So I'd like you to welcome Dr. Maibach. His title of his presentation is Using Your Trusted Voice to Deliver Simple, Clear, Effective Messages About Climate and Health. Thank you.
I pulled a fast one. I changed my title. Hope you don't mind.
Change your title. Oh, no. Okay.
And can you see my slides?
Yes, thank you.
Excellent. And I got to say, I don't know if Graham is still with us or not, but Graham is invited to my party anytime. I have about 100 questions for him, and I'm sure my wife has 250 more. That was a really terrific talk. So the talk I want to give, the thoughts I want to share are similar to the prior title, but I just wanted to frame them up a little bit differently. Earlier this month, briefly, the world actually exceeded 1.5 degrees of warming. It's time limited. It will settle back down. But the reality of the challenge in front of us, the opportunity in front of us, is that the leaders of the world at the Paris Climate Agreement set 2 degrees of warming as the global goal. And they subsequently realized that was a bit of an overshoot. 2 degrees of warming cannot be considered safe. So there is talk of and growing support for trying to limit the warming to 1.5 degrees C, if that's still possible. And as a health professional, and as somebody who studies public engagement and climate change and ways of enhancing public engagement to build both public will for climate solutions, as well as, more importantly, political will for climate solutions, I've become convinced that we, health professionals, we have a necessary and unique role to play to help the world rise to this challenge. And so that's what I want to talk about today. But before I do, I want to disclose my conflicts of interests. Okay, I know that is an important thing to do, and I have some. My conflicts are that I've decarbonized my life to the fullest extent possible. Not entirely decarbonized, because I do still travel by airplane occasionally. But I've also divested my savings from investments in fossil fuel companies. And I am all in on accelerating the transition to a clean energy economy, both at work and through my work. And if these don't strike you as conflicts, well, that's good. They don't strike me as conflicts either. But for those who feel like, because I'm a true, as I said, I'm all in on this. If that strikes you as impairing my judgment in any way, shape, or form, there, I've disclosed it. And I'd like to start actually with a story. It's a story that I find to be enormously heartful. It's one that allows me to get up every morning and give my best shot at helping the world rise to this challenge in front of us. It's the story of the International Physicians for the Prevention of Nuclear War. These 7 American and Soviet physicians who established IPPNW in 1980, they had a simple, clear message for the world. Their message was that a nuclear war would destroy civilization and might extinguish human life. That's a very powerful message. And I want to actually change what I said a moment ago. This was not their message to the world. I mean, in fact, they did want the world to know this message, but it was really a message to 2 people, to Ronald Reagan and to Mikhail Gorbachev, the 2 people who had the political power to sign a nuclear test ban treaty. And this was their message to them. 5 short years after starting to communicate this message to those 2 men, they won the Nobel Peace Prize for their central role in helping open arms control discussions between our 2 nations. And that's pretty damn amazing. But winning a Nobel Peace Prize is nice. It doesn't necessarily change the world. But IPPNW did change the world. And the way we know that is because Mikhail Gorbachev told us about it in his autobiography published in 1987. He said, "Their work commands great respect, for what they say and what they do is prompted by accurate knowledge and a passionate desire to warn humanity about the dangers looming over it. In light of their arguments and the strictly scientific data they possess, there seems to be no room left for politicking, and no serious politician has the right to disregard their conclusions." Wow. Now that's impact. It gets even better though, because 5 years after that, he wrote a thank you note to the executive director of IPPNW. Classy guy writing thank you notes. And he said, "I want to thank you for your great contribution to preventing nuclear war. Without it and other effective anti-nuclear initiatives like this, the treaty probably would have been impossible." Initially 7 people, 7 concerned health professionals, made the impossible possible. And that, my friends, is a beautiful story that gives me heart every day, that gives me heart and hope every day that we can make a difference. So with that story as my springboard, let me talk about why I see this limiting global warming to 1.5 to 2 degrees as a necessary role for us. Why us? Is this our lane? And I would say, yeah, this is absolutely our lane. This is really the most important public health goal of our era. That is why I, for the past 16 years now, that's why this is all I've done. I'm a public health guy, first, foremost, and always, and I've worked on some really great public health challenges, including the global HIV epidemic. And I had enormous heart for that and for fighting the tobacco industry and for being part of the first anti-vax first effort to fight anti-vax activities that were emerging in the late 1990s. And I loved all of that work. I had enormous heart for all of that work. But once I really wrapped my head around the enormity of what climate change is doing to human health and well-being, I knew this was my real calling. After, in 2015, 197 countries in the world ratified the Paris Climate Agreement to limit the warming to no more than 2 degrees. But the leaders of the world pretty quickly thereafter realized, well, that might have been a politically expedient goal, but it might not be a goal really informed by science. So they put the IPCC back on the job, and they had them issue this special report, the IPCC special report on global warming of 1.5 degrees C. And the basic idea here was to answer the question, is 2 degrees of warming safe? And the key finding, I'll go right down to the one sentence that means the most to me. The key finding is that every 10th of a degree of warming above 1.5 degrees C has grave public health consequences. And this is such a meaningful sentence to me, in large part because it's pretty clear we're not going to limit the warming to 1.5 degrees C. But this sentence helps me understand that all is not lost, that every 1/10 of 1 degree of warming that we can still prevent will have amazing public health benefits to human health, to our future generations. And that's the perspective that I bring to my work every day. That is the perspective that I urge you to bring to your work in addressing climate change. You have undoubtedly heard, and you will undoubtedly continue to hear, that all is lost. We can't limit the warming to 1.5 degrees C, therefore we should stop trying. And if there's only one thing you take from my thoughts today, that the one thing I want you to take is that is just wrong-headed thinking. Every 1/10 of a degree of warming that we can prevent is a profound gift to human civilization going forward. So I got my public health training, my MPH in 1982, I think, and in 1982, and really all the way up until the present, tobacco has been seen as the leading preventable cause of morbidity and mortality worldwide. And I don't mean to diminish the threat of tobacco as a public health foe by any means, but I want us to take a step back and look at what actually is even a bigger threat to public health and well-being than tobacco, and that is fossil fuels, okay? So looking at only the air deaths, premature mortality from fossil fuel air pollution, as compared to premature mortality from tobacco. And this is just one way in which climate change is harming health, but just air pollution alone is a bigger public health foe than tobacco. And it's not just premature mortality, it's the morbidity that comes with it. Of course, tobacco carries a lot of morbidity as well, but the morbidity associated with air pollution is absolutely profound. It occurs from before birth, so to the extent to which pregnant women are exposed to air pollution, there are bad birth outcomes, low birth weight, stillbirth, preterm. neurodevelopmental problems with the children who are born, ADHD, reduced IQ, autism, and then, of course, all of the more well understood impacts of childhood exposure to air pollution, asthma and chronic bronchitis, and then all of the adult morbidity as well, with the final bullet point on this page being one that has only now begun to be appreciated, and that is, just like childhood exposure to air pollution carries all kinds of neurodevelopmental burdens for children throughout their lifetime, at the end of lifetime, or a person's lifetime exposure to air pollution carries a similar neurodegenerative burden in the form of Alzheimer's and other dementias and Parkinson's disease. These are very substantial health burdens. And this is from a preventable source, a source that we've come to think of as endemic, but it doesn't have to be endemic. There's so much we can do to make air pollution history. And again, air pollution is only one of 8 pathways by which climate change is harming our health. In addition to all of that health burden from exposure to air pollution, there's the dangers of extreme heat, other forms of extreme weather, vector, water, and foodborne illnesses, all of which are being made exacerbated by our changing global climate, all of the impacts on hunger and malnutrition in its many forms. And then finally, the one that I hear on so many people's lips, and so many people seem really worried about it, that the mental health burdens associated with climate change, both the acute burdens, the PTSD associated with being exposed to a climate catastrophe, as well as the chronic mental health burdens associated with just anxiety and depression about understanding what the future might hold unless we rise to this challenge. This graphic is produced by California Department of Health. It's a modification of a graphic produced by CDC. I won't go into it. It's simply just a much more articulated version of those 8 health pathways. Actually, they break it, CDC and California Public Health break it down into 10 pathways. But the bottom line here is that climate change is harming our health in so many different ways. And the primary root cause of that is burning fossil fuels. Earlier this year, my dear friend Courtney Howard in Canada and about 24 other colleagues and I published a paper in Lancet Planetary Health to make what we consider to be an important point. And for me, again, I contextualize this important point in the context of my own career in public health, which 40 years ago started with a focus on the behavioral determinants of health and how important that seemed 40 years ago. And about 20 years ago, public health pivoted to focus primarily and correctly on the social and the structural determinants of health. But where I think we need to pivot now is to look at the ecological determinants of health, because climate change and other ecological determinants of health, if we destabilize them, we're also taking down or eroding the social and structural determinants of health. We are also directly damaging and impeding the readiness of the health systems, our health systems, at exactly the times when we most need them to be at full functioning. And as I've already talked about, we're harming human health directly through a whole variety of different pathways. So why do we need to focus on this? Why is this a necessary role for us? Because by destabilizing the ecological determinants of health, we are undoing all of that good work that we collectively have done for the past 100 years or more to dramatically improve human health and well-being. And this is sort of my fundamental conclusion, that our climate and our health have a common enemy, and that common enemy is fossil fuels. We needed fossil fuels in the 20th century to bring hundreds of millions, billions, in fact, of people out of poverty. But that was last century. We're now in a new century. Fossil fuels are no longer our friend. I think of them as a profound threat and a profound enemy of our common health and well-being. The IPCC which is recently, last year actually released their sixth cyclical report. I won't go into all of the details, but there's a very powerful health chapter. This is the executive summary box. I'll simply say it is a repetition of what I've already said, that the climate change is a powerful threat to our health and well-being. It's already having dramatic impacts. But rather than dwell on what the IPCC said in their report, I want to dwell for a moment on what UN Secretary General Antonio Guterres said about it. So in responding to this report, he said, there's no kind way to put it. We're sleepwalking to climate catastrophe. The 1.5 degree C goal is on life support. It's in intensive care. And notice how this gentleman, who does not have any health training at all, how he is using medical metaphors to express his profound concern about the rapidly deteriorating ecological determinants of health. He went on to say in the same press conference, he went on to say that nearly half of humanity is living in the danger zone now. Unchecked carbon pollution is forcing the world's most vulnerable people on a frog march to destruction now. And then he said, delay equals death. For me, having worked on the global HIV epidemic, those three words are particularly powerful. For those of you who are old enough to remember the early days of the HIV epidemic, then the three words, silence equals death, were transformative in changing the way the medical community and the public health community and the HIV patient advocate community work together to change clinical research and the public health approach to fighting the HIV epidemic. I am hoping that these three words, delay equals death, are equally transformative in the way we are addressing the issue of climate change. So in summary, that's why I think this is a necessary role for us. This is our lane. It is, and anybody who tells us otherwise, we have an obligation to give them a schooling, give them an education on just how profound the threat of climate change is to human health and well-being, climate change as well as the fossil fuel economy. But the next thought I want to share with you is, okay, so what's our unique role? Clearly, this is a necessary role, but what is our unique role as health professionals? When Tony and I started the Climate Change in the American Mind poll back in 2008, we learned very quickly that most Americans, even back in 2008, most accepted the fact that climate change is happening, but most Americans saw it as a distant threat, a distant problem in time, in space, and in species. All three of those types of psychological distance meant that people weren't necessarily focused on what does this mean for me, and what, if anything, should I, and what, if anything, should we collectively be doing about it? When our problems are psychologically distant in space, time, and species, we think of them as somebody else's problems to deal with. Before we ask people in our surveys, the Climate Change in the American Mind surveys, before we ask people any other questions about global warming, we ask them this question: what's the first thing that comes to mind when you hear global warming? The reason we ask this question is top of mind associations are so revealing of the way we think and feel about any issue. So we could take out the words global warming and we could substitute any other words you wanted. Gun control, Second Amendment rights, doesn't really matter. The best way to understand how people really think and feel about an issue is to ask them in their own words, what do you think and feel about the issue? What comes to mind first? And this is what we've learned over the past 15 years. Back then, as is true now, for most Americans, the top of mind association is plants, penguins, and polar bears. Most typically, we hear about polar bears. And that's because most typically, media portrayals over and over again, they show us visual images of polar bears. They're rarely as happy as this guy looks, or gal. I'm not sure if it's a boy or girl, but this is, You know, this is an image, some derivation of this image is something we've seen over and over and over again, and it has absolutely shaped or worked its way into the middle of our mental model about how we see the issue of global warming. The second most common association we get in response to that question is something to do with science. And like the polar bear, which is not a personally relevant reference. So when we hear about polar bears instead of people, it tells us, it confirms right off the bat, this is not something that people think is all that personally relevant. Same thing when they give us a reference to science. Science is interesting. Lots of people think so, but interesting and personally relevant are two totally different things. The third most common association we hear is to politics and politicians. And this is not, trust me on this one, my friends, this is not a positive association, because when we reference back the specific names or the specific party that is mentioned, it's always coming from somebody from the other party. So when we hear about Al Gore or Barack Obama or Nancy Pelosi, or now most recently Joe Biden, we are almost always hearing that come from people who are either unaffiliated politically or who are Republicans. When we hear about Mitch McConnell or ironically Joe Manchin, who announced yesterday he is not running again, it's almost always from Democrats. So these are emotion-laden comments, but these are not comments that reveal, again, a personal connection with the issue. Increasingly, over the past 15 years, we've seen this as a reference. Dangerous weather, extreme weather, that this is not an accident. A big part of what I do is work with the broadcast meteorology community to enable them to educate their viewers about the local consequences of global climate change. We know it's working. We've published lots of evaluation studies to prove it's working, but this is the most compelling evidence to me. The fact that in our top of mind, in the answers to this question, we're seeing increasing references to extreme dangerous weather. But we never hear this. We never hear references to people's health, my child's health, my own health, my mother's health. This is the kind of personal reference that I want us to hear more frequently going forward, because as we hear this kind of reference, that's when I know we're winning. That's when I know people are making the connections between global climate change and the thing they care most about, the health and well-being of their family. In 2021, we asked another open-ended question. We said the question was, what do you think is the greatest threat that global warming poses to the United States, if any? Again, this is open-ended. We're asking people in their own words. We didn't give them any of these categories. We coded their answers and came up with these categories. In 2020, weather extremes and changes in the weather were the most common. Health harms was way down there. Only 3% of the public mentioned health harms. Although I gotta say, in this 2021, excuse me, I consider this something of a victory for 2021, because trust me, when we started this polling back in 2008, it would have been 0%. So we're making a little bit of headway, but we've got a whole lot left to do. When conversely, when we ask people closed-ended questions, so this is a question we ask in every one of our surveys, in your opinion, do you think global warming is an environmental issue, a scientific issue, an agricultural, farming and food issue, a severe weather issue, etc.? People give you different answers, all right? So we just saw back here, only 3% consider health harms to be top, in their own top of mind associations, health harm is the biggest threat. Here we see that 6 out of 10 Americans tell us that this is a health issue. But I think what we're seeing here is that people who are convinced that global warming is bad, when we ask them more specific ways, well, is it bad because it's an environmental issue? Is it bad because it threatens our food? Is it bad because it's making our weather more extreme? They essentially answer a question that they don't really know the answer to with the answer to a question they do know the answer to, which is global warming is bad. So we know that 7 out of 10 Americans are worried about global warming, and that is essentially exactly what we're seeing. People translating that concern, that worry, into instant judgments about the ways in which it's bad. But in 2015, we published a paper which showed that very few Americans can name a single way in which global warming is bad for their health, or can name a single group of Americans who are at greater risk of health harm from climate change. But this, trust me, I don't like to be the bearer of bad news. I like to be the bearer of good news. So here's some good news. We asked this one battery of questions in 2014 and again in 2020. The battery of questions is essentially, do you think that each of the following conditions will become more or less common in your community over the next 10 years as a result of global warming, or will it stay about the same? Okay, so more common, less common, or no difference. And the battery of the items that we ask about, they're essentially every one of these is an actual health impact of climate change. And I don't want you to get caught up in all the numbers. I want to present you with a simplification. In 2014, about 1 out of 4 people, maybe as many as 1 out of 3, said, yeah, these things are going to become worse in my community over the next decade because of global warming. And today, it's more like 1 out of 2. Half or more of Americans say these things are going to become worse in my community these health problems will become worse in my community as a result of global warming. So we are definitely making progress on spreading the word about what we know to be true, that climate change is a profound human health threat. In my 42 years now as a public health communication professional, this is the one thing that I have learned with greater certainty than anything else. The way that public health communication campaigns work, the ones that do work, they all work based on this formula. Simple, clear messages, repeated often by a variety of trusted and caring voices. In fact, this is the evidence-based this is an evidence-based formula that is at the heart of all public communication campaigns, not just health communication. This is what works. This is why Donald Trump is such a brilliant communicator. He has simple, clear messages. He repeats them often. And because he's got simple, clear messages and he repeats them often, a variety of other people who trust him put their own trusted and caring voices to spread these messages. Trust me, I am not a fan of the messages that the simple, clear messages that Donald Trump is spreading, but I do want to take my hat off to him and acknowledge the fact that he is a brilliant communicator. And if we want to become more brilliant communicators, we need to learn from his successes, but there's also 40 years of research in public health communication that has led me to call this evidence-based guidance for effective communication campaigns. So let's start with the last part of that formula, trusted and caring voices. So this is data from our survey in spring of 2022. We ask our respondents, how much do you trust or distrust the following as a source of information about global warming? Now, if you look at the left-hand side of the slide, you'll see that NASA is the most trusted voice by registered voters across the political continuum, or in total, NASA is the most trusted. That's a beautiful thing. NASA does a very good job of climate education, but it's very passive. You can come to NASA's website and get a darn good education about climate change, but if you don't come to their website, you won't encounter that education. Second most trusted source, friends and family. That's interesting. Third most trusted, climate scientists. That's also interesting, but not 1 in 100 Americans could name a single climate scientist. So that's sort of an idea more than a practical reality. But look at the fourth one, your primary care doctor. Now that is a communication insight, because it tells us that people trust their doctors as a source of information about global warming. Now, let's look all the way across the slide to the column that shows data for only conservative Republicans. And actually, you can look at both slides in red or pink, moderate Republicans and conservative Republicans. They place They trust everybody less than do the liberal and moderate Democrats, but they trust their doctors more than almost anybody else. So conservative Republicans only trust their friends and family more than they trust their own doctors. That is a huge, a colossal communication opportunity. And that is sort of the essence that led me to believe we have a unique role, because conservative Republicans and moderate Republicans tell me in response to our surveys that we have a unique role. We health professionals are seen as trusted sources for Americans who most need to have their minds open on the issue of global warming. We take our survey data, and through a whole variety of other types of research, message testing research, we have learned that there are essentially what I call, these are 6 key facts about global warming, but I also call them 6 key truths about global warming. And these 6 key truths, people who understand them all, or the degree to which people feel confident in them, it's strongly determinative of how worried they are about the issue and how likely they are to be rolling up their sleeves and doing anything about the issue. And the 6 key truths are incredibly simple, clear messages, if you will. It's real. Global warming's happening. It's us. Burning human activity, which I'm moving away from that phrase because it's so abstract. Burning fossil fuels is the main cause. The second main cause is burning down the world's, knocking down and burning the world's forests. Experts agree. No matter what you've heard on Fox News or anywhere else, there is no disagreement among climate scientists. They are all in agreement that human-caused climate change is a reality, and they all think it's bad, which is the 4th point. It is bad. It's bad in a whole variety of ways. And me, as a health professional, I'm here to tell you the ways in which it's harming our health. Other people care. So if you are in the large majority of Americans who are worried, who care about climate change, and if you feel like you're in a minority, it's not true. Most Americans care about it. Most Americans are worried, yet most Americans also think they're in a small minority of Americans who are concerned about this issue. And that just isn't true. Lots of other people care. And finally, there's hope. There are so many things we can do, so many actions we can take that will make a profound difference, that will shave so many 1/10 of 1 degree off of the eventual top of the global warming curve that humanity will face. In fact, we've already, over the past, since the signing of the Paris Climate Agreement in 2015, we've already taken more than, I think it's more than 12/10 of a degree off the most likely trajectory of global warming. So we have already made a profound difference over the past 8 years. But let's talk a little bit about sort of how to make the case that climate change is harming health. When we launched the Medical Society Consortium on Climate and Health, which I'll tell you a little bit more about in a moment, but when we launched the Medical Society Consortium in 2017, we launched it with this report, which is the cover of which is depicted in the upper right, the Medical Alert Report. And we did a whole bunch of message testing research to serve as the basis of deciding how to explain why we in the Medical Society Consortium, why we see this as why we wanted to issue a medical alert. And what we did is we took those 8 pathways by which climate change is harming human health. These were the 8 pathways that were explained in the 4th National Climate Assessment, the health chapter, essentially laid out these 8 pathways. And we wrote a brief, simple, plain language explanation of what's happening to our climate, how is that harming human health? So how is air pollution harming human health? How is extreme heat harming human health, extreme weather, etc.? And whose health is being harmed first and worst? Often, almost always, it's babies, children, pregnant women, seniors, people with chronic illnesses, people who from low-income and communities of color, and people who earn their livelihoods by working outdoors, okay? So essentially, each of these essays, each of these 8 essays, 150 words, We had people rate each essay in terms of how new is this information to you? How clear was this? How helpful was this? How likely would you be to share this with people you care about? And what we learned is that this was meaningful information to people. We asked people both before they read these essays, again after they read the 8 essays, and then 2 to 3 weeks later, we asked them a series of questions to gauge their degree of cognitive and affective engagement with the issue of climate change. And what we learned is that reading these 8 short essays, which are published in the Medical Alert Report, people, especially moderates and moderate conservatives, became more engaged in the issue. For the first time, they started to see the personal relevance of this problem. And that's good news, okay? That's really helpful. The next report that we issued several years later out of the Medical Society Consortium, it was the other side of the coin. The fact that climate solutions are also health solutions, that things that we can do to be kind to our climate are profoundly good for our health. And we boiled those down into what I call these 5 policy solution pathways: clean renewable energy, climate smart foods, clean and active transportation, improved buildings and homes, and improved community environments. And we tested these as well. But before I show you the test results of that, just want to make the point that when you talk about the climate benefits of these policy solutions, the climate benefits take decades to accrue, and they accrue a little bit everywhere. But when you talk about the health benefits of these policy solutions, they accrue almost immediately. When we take these actions in our community, our health benefits almost immediately, and we are the primary beneficiary of those actions. So when we shut down the coal-fired power plant upwind from us, we are the ones who get to benefit, and we benefit almost immediately. So talking about the health benefits of climate solutions brings all of that problem of the fact that people don't like to invest in things that take decades to pay benefits to, and that pay benefits everywhere. So we have the secret sauce, if you will, to make the benefits of the solutions immediate and personal. And sure enough, when we conducted a study where we essentially created 376 versions of messages about the health impacts, showing those, featuring those 8 health impacts that I talked about a moment ago, featuring the 5 policy solutions that I talked about a moment ago, and then closing with a variety of different ways of issuing a call to action, if you will. What we found is that the messages that had all 3 of these types of information were the most effective. And of these 3 types of information, the one that had the biggest impact was talking about the benefits, the health benefits of the types of climate policies that every climate expert knows will make a big difference. And this was, yet again, these messages were even more, were actually equally effective for conservatives as for liberals, which is that alone is a huge victory, because part of the problem of information is it can increase polarization. But this climate and health narrative, this talking about the health impacts, the health benefits, and affirming the fact that if you care, you are in the majority. So join us, the people who are taking action, and let's fight for these smart climate and health policies. This works equally well for conservatives as for liberals. Most recently, actually this very week, this paper was published in Lancet Planetary Health. A third paper that came out of our team, and this paper asked the question of, well, most of us health professionals, we actually believe in sort of civil demeanor. We don't tend to call out people by name. That's not really, we sort of feel like that's not fair play. Of course, that's the way politicians work, but that's not really the way we usually roll. But we felt that it was really important to test, should we be calling out the fossil fuel industry when we make our appeal to the public and to policymakers? If these we are confident that though these 5 policy pathway solutions are profoundly good for our climate and good for our health, but we know that there are forces out there who are opposing these policy pathways. So the question became, does it help if we point to them? And we specifically acknowledge that we have opponents, and the opponents that we tested were fossil fuel CEOs and their lobbyists in some of in one condition. In another condition, we said some politicians, they were the opponents. And in the third condition, we said fossil fuel CEOs and their lobbyists and the politicians who are in their pockets. And what we learned is that compared to the optimal climate and health message, the one that looked like this, when we added in calling out the opponents, any one of these 3 approaches, all of these 3 approaches worked really well, particularly this bottom one. When we called out fossil fuel CEOs and their lobbyists and the politicians who are in their pockets as being the ones who are trying to stop us from implementing these climate and health smart policies, it made people, particularly Republicans and independents, more likely to actually take the kind of action of clicking on a link in the message that we gave them and providing their name and email address to an advocacy organization who was going to weigh in with politicians in support of climate and health solutions. So all of these lines of evidence is why I'm convinced that we have this unique role, because what we can do is we can make the problem personal in ways so few other trusted voices can. We can bring the benefits of solutions into the present and into our communities, and we perhaps uniquely can help to depolarize the issue, perhaps even extract the issue out of being part of the culture wars in America. That's the kind of trust that we have. That's the kind of opportunity that we have. It will require work. It will require patience and perseverance, but this is what we can accomplish. This is why we created the Medical Society Consortium on Climate and Health, because our trusted health voices, we can engage with the public, we can engage with policymakers, and the simple, clear messages that we can bring forward, as I've already showed you, have a profound effect at helping people understand how this is a personally relevant issue, and it works among the people across the political continuum. I am so happy to call myself, I don't know what my friends at Healthy Climate Wisconsin call me, but I call myself an honorary member. I am so proud of the folks at Healthy Climate Wisconsin, which is a state affiliate of the Medical Society Consortium, because what they are doing in Wisconsin is really profound. They are taking all of these lessons, all of these insights, and they're putting them to work for the benefit of everybody in Wisconsin. So there's a whole variety of different ways that each of us can help. We can join the climate and health movement. We can help to build public will for these kinds of solutions. We can engage directly with policymakers to build political will and corporate will and institutional will for these smart policies. We can conduct research of consequence. You know, this is how we focus our research project, our program at my center, the Center for Climate Change Communication, but there is so much research that is needed. I encourage all of you to do this, and fundamentally, we can lead by example. We can do the right thing in our private lives and our professional lives, because leading from the front is a much more powerful position to be in than leading from behind. So for those of you who want to lead, I invite you to join me in merging your trusted voice with mine. I want to make fossil fuels history. That's an important part of what we need to do, but not the only part of what we need to do. For those of you who are in Wisconsin, and I realize not everybody in this conversation today is from Wisconsin. For those of you who aren't members of Healthy Climate Wisconsin, point your camera at the black QR code. That will take you to their website. Give them your name and email address, and you will be a member. For those of you who aren't in Wisconsin, come join us at the Medical Society Consortium on Climate and Health, the green QR code. We need your voice to help us Advocate for climate smart policies on Capitol Hill. We have members all over the country, and it really strengthens our effort to have those members. For those of you in Wisconsin who aren't also members of the Medical Society Consortium, I encourage you to join us as well. These are two really important opportunities for you to become part of the climate and health movement and to advocate for smart public policy in your state and in our nation. So with that, I cede the microphone back to our hosts. And if any of you have questions, I'd be happy to take them. Although I have to say, because we got a little bit of a late start, I am now expecting a doctoral defense in 5 minutes. So I can't stay too much past the top of the hour.
We do have some time. So if we have written questions. I would say our people who are online, are there any online questions? We'll give you the priority here. You can raise your hand.
Update, if you're online, please post in the chat. Thank you.
Yeah. Okay. Not having, is this oh boy. Okay, I'll start. Yeah. Given that wind and solar aren't currently able to totally power the grid, what is your opinion on nuclear power to replace fossil fuels? Again.
Yeah. Okay. So I'm a public health guy, right? I'm not an energy policy expert, but like all of you, I have an opinion. My own opinion is that nuclear is an investment that takes decades just to get the darn thing operational. Decades. And over the past several decades, it has been so commercial, so economically non-viable that even the projects that get started don't get finished. So while nuclear is clearly clean energy, it's not clean energy that seems to be economically viable or that anybody seems to be willing to put their money behind. So in concept, yeah, it looks really good on paper, but in practical reality, I just don't see it as being a part of the solution set.
Thank you. Next question. Is there a risk for docs being too passionate about this that could reduce societal trust in the physician community? Example, doctors who ask if firearms are in home and locked have lost patients.
So my friend Andrew Lewandowski, who may be with us today, I have no idea. He's a pediatrician in Madison. Andrew thought that Andrew's a man who's very concerned about climate change and sees it as being directly relevant to the children in his practice. And he conducted a little pilot test. He wanted to know how would his families react if he incorporated a brief element into his well-child counseling visits. So he wrote a 45-second script, and he essentially brought that into his debrief for his childhood patients and their parents. And for 250 consecutive well-child visits. And then he sent those families, he either gave them a paper and pencil questionnaire, or he sent them an email to their home email address to ask them, how did you feel about the fact that I brought up climate change in the context of your visit today? And what he learned was really incredibly heartening. He essentially got almost no pushback. Very, very, very few of his families had anything negative to say about it. He asked them in his questionnaire where they fell on the political spectrum. His families were probably 2-to-1 Democrats versus Republicans, but even among the conservative or the Republican families that he is serving, they actually saw value in what he said. They responded well, which really confirms what I showed you from our polling data, which is that even conservative Republicans, they have a lot of trust in what their doctors would have to say about this issue. So I think as long as you stay to the evidence and why you care. So Marshall Gans at Harvard talks about the importance of invoking the story of self first, like, this is who I am and this is why I care, before you explain what it is you care about. I think as long as you keep it to you as health professional, you're going to be fine. If you make it about you as liberal Democrat, it's not a good idea. People don't really want to hear what you have to say. I mean, maybe other liberal Democrats want to hear what you have to say. But everybody wants to hear what you have to say as concerned health professional in their community. So as long as you invoke who you are as a concerned health professional and you keep it focused on the factual reality and keep your own personal politics out of it, I just don't see any significant downside potential.
Thank you. Just a question for you. Do you see any specific or have any specific recommendations of activities that we can do locally? I mean, the environmental network here gets invited and we go out to do grand rounds and whatever at the various hospitals. And part of the challenge is we can give them the information, the science, and what they want to know is a project like you just described, just take 30 seconds to do X, Y, Z, and that'll make a real difference. What can we do to implement things in some of these communities? And many of these that we've been going to are rural communities in Wisconsin, which tend to be a little more conservative than other areas. So any suggestions on here's a simple, easy thing that you can do that we know has been successful in other circumstances?
Yeah, well, number one, join the climate and health movement, right? So that we are more powerful together than we are alone. So I think that's the most important thing. But the second most important thing is the answer that my dear friend Catherine Hayhoe came when she came and gave a talk at George Mason recently, a community talk and not a technical talk. And she was asked this question, what's the most, I mean, she actually she knew she would be asked the question, so she proactively answered it by saying, the most important thing you can do is use your voice. Tell people in your family, friendship network, your neighborhood, your work, your coworkers, every opportunity you can, tell people how concerned you are, why you're concerned, and what you're doing about it. That is because, and we as health professionals, especially when you go out to conservative rural communities, you're giving people information they have never heard before. And you're using that privilege that you have, that trusted privileged position in the community in a way that is so, so powerful. So that's the simplest, most important thing you can do. But also trust that the climate and health movements that you join, that they're going to tell you when there are opportunities for you to use your voice collectively to try to influence policy decisions. For example, in this town, there is going to be a town hall meeting, and here is the proposition that will be considered. We really think it's important for health voices to be heard in response to this proposition, because we think the proposition is bad for health and well-being, and we need health professionals there. So trust the fact that the organizations that are supporting us as individuals will amplify our collective impact, but also realize the single most important thing we can do is use our voices.
Thank you. This follows up then this question. How do you deal with the link between climate change and politics, and that some Americans seem to be not trusting now more than ever of science?
There has been, this is data I look at very carefully, loss of trust in scientists and science, and loss of trust in health professionals. I know the pandemic feels otherwise, but the systematic loss of trust in health professionals is very small and mostly confined to the right. The systematic loss of trust in scientists is somewhat larger, but not nearly as profound as some of us are fearful of. So if it feels like an objective reality of us of feeling the heat in our communities about policies that have made lots of people unhappy, it really hasn't caused a systematic loss of trust in us as professionals. It's just that people are unhappy, period. And we're particularly unhappy about pandemic-related things. Trust. I ask you to trust that we retain the trust of members of our community. We see it in the data. And if you believe in people, they in turn will believe in you.
Thank
With
you.
that, with that, I actually have to go because this is one of my doctoral students who is defending, and it would be exceedingly rude of me to miss his defense. So I thank you all for the invitation to be with you, and I hope you have a wonderful rest of your conversation.
Thank you.
All right. Is this on? Yeah, I think so. It is now time for our snack break. If you have to use the restroom, otherwise we have snacks set out. Help yourself, about 15 minutes, and we'll reconvene for Dr. Handelsman's presentation. Also, just so everyone is aware, Dr. Maibach was our 2023 Henry Anderson lecturer. So he was our distinguished lecturer. All right. Thank you, everybody. Can those of us on Zoom hear? This does.
Hello? Can you hear me? Raise your hand if you can't hear me. Okay, welcome back and thank you for coming back, and I hope you had a good break. So my name is Susan Davidson and I am a physician specializing in high-risk obstetrics, and I've been on the WEHN steering committee since 2011. I got interested in this because as a physician, I did a lot of prenatal diagnosis and ultrasound, and I noticed a lot of birth defects that I thought were sort of strange, coming from the rural areas. So I got very interested in the area of birth defects and the environment, and that led to a bigger interest in health and the environment. And I just want to say that Henry talked about our speaking, and many of us from the Wisconsin Environmental Health Network are available for speaking. We speak to large groups, we speak to small groups, we speak to medical professionals, we speak to community groups, churches, whatever, big or small. If you have a community group that you think would be interested in learning about the environment and health, please contact us and we will arrange for somebody to come. So it is indeed my pleasure to introduce our next speaker, Dr. Jo Handelsman. And I want to say that Dr. Jo has been invited to my party. She is the director of the Wisconsin Institute of Discovery at the University of Wisconsin here, a virus research professor and the Howard Hughes Medical Institute professor. She has previously served as a science advisor to President Barack Obama as the Associate Director for Science at the White House Office of Science and Technology. She has been on the faculty of the University of Wisconsin-Madison and of Yale and we are lucky that she came back to us. She has authored numerous articles, over 200, written 30 or 40 editorials, chapters and books, etc. And she has also written this book, A World Without Soil, which I will say is great bedtime reading. Who knew that reading about dirt would be so interesting? So with that, Jo.
Susan, I have to wonder exactly why it's good bedtime reading. Does it put you to sleep or something else? Okay, so I am going to talk today, unlike my two previous predecessors in the program, I'm going to talk today about a very happy story. I'm going to tell you all the bad news first, but the end, I'll tell you right now, is that this is a crisis that we could fix. It's a really, really, really bad crisis, and it's going to become worse if we don't fix it. But the beauty of it is we could fix it essentially in 1 year. So unlike climate change or environmental pollution, which are so broad and not site specific, and they don't have origins that most of us can control. In fact, we have a lot of power over our soil indirectly. So I have my own land acknowledgement. I know we already had one, but I would just like to acknowledge that the Ho-Chunk people have a history of violence and struggle to remain on their land, but today they persist. Their survival is a testament to their resilience and a reminder of our responsibility to respect the sovereignty of the tribes and the opportunity to learn from their stewardship of the land on which we stand. And I add that one because the health of the land is something that's always been important to Indigenous people and much less so to European Americans. And if we followed some of the lessons from Indigenous agriculture, we wouldn't be in the mess that we're in today. And I'll talk about what those practices are toward the end. So what I want to talk about are first, what is soil? Most people walk on it. They maybe even garden in it. They build their houses on it, and they have no real idea of what it is. Although some people think it's a negative, they call it dirt, very disrespectful. And some, I think there's probably something really good about it, but they have no idea what that is or where it comes from. And then I'd like to talk about how soil affects human health, and I'm not going to cover every single advantage and contribution that soil makes, but I am going to stick to the positive of why soil is a good thing. I'm not going to be talking about soil as a route for contaminants getting into our systems, which it also can be, but I'm going to talk more about the active elements of soil that make it beneficial to health. Then I'll talk about the crisis, which is soil erosion, and some of the consequences that are pretty serious. The lessons we have from Indigenous people about how to prevent soil erosion, and what we can do to protect our soil in modern agriculture. So one of the things we know for sure is that soil forms very, very slowly. It's a geologic process from the time it starts till the end, starting with, of course, the geology, the bedrock that is under the land that we're on. After many centuries of processing by plants, animals, microorganisms, weather, and of course, time being the biggest element here, that rock becomes soil. Now, once the soil is formed, it's actually not that hard to increase the amount of soil. And that's the part that we do have influence over, and why it's so important not to lose all of the topsoil, because once it's all gone, you have to start this geologic process all over again. But for as long as you have topsoil, making more topsoil is a much quicker enterprise than what we're talking about here. And so the estimate is that to go from geologic material to a very young soil like this, where you can see there's no differentiation of the layers, to a mature soil where you can see the layers that have been processed by the microorganisms living in the soil and the weather, it probably takes a few centuries, if not thousands of years, for the full development. And so for topsoil, we know that it's a bad estimate. I guarantee it's wrong, but we make no more than 0.5 ton per acre per year of soil. That's an absolute top estimate. So that's my generous estimate so that nobody can argue with it. It's probably quite a bit less than that. So that tells you how slow this process typically is, left to its own devices. So what does soil do for us? Why do we care about this thing I call the crisis and erosion? Well, the first and obvious one that I hope everyone would think of is food security. So we, of course, depend on 95% or more of our food supply, depend on soil for 95% or more. The part of this food supply that comes from the ocean is not directly affected by soil, but it certainly is indirectly. But the rest of it, whether coming directly from plants or from animals, is created as a result of plants growing in soil. So our food supply, if soil is under threat, our food supply is under threat. The second thing that most people don't think about is the quality of our water supply. So most of the water in in civilizations across the world comes from groundwater, the water that we drink. Some other places, other sources, but most of it is groundwater. Well, have you ever thought about the fact that if you have a dirty puddle of water just sit, and I use the word dirty in this case advisedly, sitting in your driveway, by the time that water has percolated down to the groundwater and gets pumped back up and you drink it out of the faucet, it's clean. And why is that? You would never drink what's in the puddle, but you have no problem drinking what comes from the faucet. One of the big influences is the many, many feet of soil that water has gone through. And it's not just soil acting as a sieve, it actually acts chemically and biologically on the water, removing impurities, removing pathogens, and the microorganisms of the soil are a key part of this. And so the soil is our biggest water filter on Earth, and we depend on it for about 60% of the water supply, which is the amount that comes from groundwater. And when the groundwater starts to get contaminated, it means the soil is overloaded and it's not doing a great job at filtering anymore. But to maintain the purity and clarity of our water supply, we have to have soil. Biodiversity is richer in soil than any habitat on Earth, and by far, probably by factors of 10 or more in terms of the density of species. The density of life is enormous. It's about 1 billion to 10 billion organisms per gram of soil. So very, very dense life, and probably somewhere in the few thousand to many thousands of species per gram. So it's a very dense habitat that is also densely speciated. And the variety of organisms covers essentially all of the groups of organisms on Earth, from mammals to viruses and bacteria, and we'll come back to the microorganisms. And so when we have our soil going extinct, we actually don't know how much of the life in the soil also goes extinct. Obviously, if all the soil went extinct, we'd be losing a lot of species. But even if one area of soil, what if 1 acre of soil is completely gone? Have we actually lost species? Well, that's the kind of thing we'd love to know, but we just don't have the knowledge yet to address. There's some evidence, though, that some species are very, very local. And so, in fact, if we lost that particular locality of soil, we would be losing that species. So that leads us to the next item. Part of that biodiversity has been exploited for medicine in antibiotic discovery. Between 2/3 and 3/4 of the antibiotics that we use in clinical settings today come from soil bacteria. From the first discoveries in the 1930s that led to streptomycin, one of the drugs targeted for tuberculosis, to some of the most recent discoveries of new antibiotics, they're essentially all from soil. And the one exception to that is penicillin, which you probably know the story, was originally a lab contaminant. So it wasn't from the soil, but essentially every other one of the major groups of antibiotics came from soil, with a few exceptions. That's why I say about 3/4. Some of the more recent derivatives have come from synthetic compounds that are made in the laboratory, and that actually arose in the laboratory, but many of them are also based on the compounds that are produced by soil bacteria. And so when you think about the revolution that antibiotics provided for medicine and society, taking most of the members of the top 10 killers off the top 10 list for many years, that's a pretty extraordinary legacy of the soil bacteria. And there are very few habitats that have been found that have anywhere near the antibiotic production or antibiotic diversity that the soil bacteria have. So that leads to a small digression here about how we're not really being very good stewards, not only of the soil that they come from, but also of the antibiotics that we have been using. So in this audience, I don't think I have to stress the rise of antibiotic resistance. MRSA, VRE, and several other major pathogens have been on the rise since they were pretty low in the early 80s, and then have just steadily risen, and the rates of increase have largely increased or stayed the same. So there's no evidence that we're slowing it much. And that is coupled with the fact that in the 1980s, the pharmaceutical industry decided they weren't going to go after new antibiotics anymore. And so at the same time that we were just facing the worst crisis we've seen in the history of antibiotics in terms of resistance, we also slowed the isolation and characterization and registration of new drugs. And so from 1980, where in this era and before, we were registering as many as 20 drugs in every roughly 4-year period. By the 2000s, we were down to a very small handful of new registrations. And unfortunately, most of those are derivatives of old antibiotics, and resistance may cross over to the new drugs. Maybe not in some cases, but in some cases it does. And so this is really worrisome, because if you look at the shape of those curves, one goes up and one is going down at over similar time frames. We don't have the antibiotics that we once had because of resistance, and we're not generating new ones. The CDC predicts that by 2050, and WHO has made similar predictions on a global scale, that antibiotic-resistant bacteria will be the leading cause of death by 2050. Today, there are 3 million antibiotic-resistant infections in the US annually, and many of those, of course, end up being fatal because we just cannot find antibiotics to treat them. So what's going on here? The antibiotic market is still at about $40 billion per year. This is not a trivial class of drugs. It's not the biggest, it's not the most lucrative, but it's not bad. The industry left because in the 80s, they began to realize that drugs taken for chronic disease made more money. If you take Lipitor for the rest of your life, obviously you're going to be paying a lot more over time than if you take 1 dose or 7 days or 10 days of a course of antibiotics. And so that was the real reason from everything I've heard from the industry. But in fact, they didn't want to say that out loud. So the industry in the 1980s promulgated the myth that the soil is tapped out. There's nothing left to find in terms of antibiotic discovery. And so that's why they were going to stop the discovery process. And that actually was patently untrue, both in terms of the reason that they left the market of antibiotics and that the soil was tapped out. There was actually no evidence to support that. And there's a lot of evidence in the probably 40 or so years since then that that's simply not true. So my lab started thinking, we work on antibiotics, and we started thinking that if perhaps we could make the route to discovery a whole lot easier, we could entice the industry back in, because a lot of the costly process is the initial discovery of antibiotics, screening of soil bacteria, and then the laborious testing that has to go on to see if the antibiotics are useful. And many of the antibiotics today that you find are certainly antibiotics that were discovered before. So even though the soil isn't tapped out, there is a problem of rediscovery of the old antibiotics that we didn't have in the 1940s because we didn't have the arsenal of antibiotics that we have today. So if we could avoid the rediscovery or reduce the rate of rediscovery, perhaps we could make it a much more efficient process and the industry would come back in. And there are still, fortunately, a couple of companies, Merck and Roche, I believe, are still trying to discover new antibiotics on their own. And many others market the old antibiotics. They just reformulate them and put the same drug out there, which doesn't do anything for the resistance problem, but at least we have companies making the antibiotics for use. And so from talking to the companies that remain in the discovery process, they agree with this approach, that if we could make that discovery process far more efficient, that would cut the costs sufficiently to maybe entice either startups or some of the old big pharma companies back in to antibiotic discovery. So I was all excited when I moved from here to Yale. As much as I missed Wisconsin, I thought one of the advantages of Yale is that right down the street, literally half an hour away, is Pfizer. And they were one of the big antibiotic discovery companies and just had an absolutely magnificent research program on the streptomyces and actinomyces, the main organisms that produce the bulk of antibiotics from the soil that have been used in medicine. And so I was all excited about collaborating with them and finding out everything from inside the industry. And I was just settling my lab 3 months into my time at Yale, and they made the announcement that they too, like almost all of the other drug companies, were leaving antibiotic discovery. And so I was very frustrated because that actually was an attraction of being in Connecticut, and not certainly the only reason I went there, but it really was important to me because I thought I'd finally have an industrial collaborator, which I didn't have in Wisconsin. And so I just got so irritated, and I have to admit, my mother had died of antibiotic-resistant bacterial infections. So this is a very personal issue to me, that here we are in this massive health crisis, more and more people dying of antibiotic-resistant bacteria, and yet another, what I thought was responsible big pharma company is pulling out. And I just stamped my foot and I said, well, if the drug companies of the world aren't going to do it, I'm going to have the undergraduate students of the world discover antibiotics. So we'll see in the long run if we show them up. And that was what became my program, Tiny Earth. This is an undergraduate research course, which is undergraduate research courses are organized research programs where students do research with other undergraduates. And there are all sorts of reasons why this is extremely effective in exciting students about STEM and keeping them in STEM. About 60% of our students, our undergraduates, who start out very excited about STEM, planning to major in STEM, leave STEM. And it's not because they can't do it. It's not because of bad grades. Their grades are essentially the same curve, bell-shaped curve, as the students who stay. They leave for other reasons, and it mostly has to do with the way we teach. Well, if they take early in their career in college, if they take a research course, they are far more likely to remain in STEM because they have the excitement of what science is about, the discovery and the thrill of learning information that nobody else has. And so several people had developed terrific undergraduate research courses, and I decided, well, why not? If we could do this on a large scale, we could have all these undergraduates discovering antibiotics. So we developed a course. We do a very intensive training for the instructors because a lot of them are not microbiologists. And so we train them so that we make sure that both the science is right and the pedagogy is right. And we now have a network of about 700 faculty across the world who teach about 14,000 students per year. And that's growing all the time because we train more and more. And now we have we train trainers to train others. So it's an amplified process. So we now have this great network across the world in which the students go through the basic process that the drug companies used for years, which is going out and taking a soil sample. The difference here is that the students are choosing the soil samples that are convenient for them and of interest to them. And I guarantee that's a different profile of soil than the companies were exploring. They collect the soil and bring it back to the lab. They culture from the soil whatever bacteria will grow on whatever media they're interested in. And that's a whole nother story of discovery where they have done such unusual combinations of soil and media that they in fact made some discoveries very early on. My first class at Yale made a discovery that was previously unknown. And it involves a medium called PDA. And I love when I talk to pharmaceutical people, the old guard who did antibiotic discovery for years, because they say, what's PDA? And of course, it's because I'm in a plant pathology department here. I had learned potato dextrose agar is like the backbone of plant pathology culturing, and none of the pharmaceutical companies ever heard of it. And so just by accident, one of my students made a really cool discovery based on using PDA. So then they isolate the bacteria, so they're working with pure cultures, and then they test them for antibiotic activity against a whole series of relatives of the escaped pathogens. If you know the pathogens of the infectious disease Society of America has listed as the top threats. We use close enough relatives that the sensitivity of those organisms is relevant to the escape pathogens, but we're not putting the students at risk. And then we at Madison, unless the students have the access to the right labs or their instructors work with a chemistry course, we do the chemistry here at Madison in the Wisconsin Institute for Discovery. And so one of the things that we think is leading to some pretty intriguing discoveries is the fact that, first of all, we are focusing a lot on gram-negative bacteria, which was not a focus of the pharmaceutical industry. And one that I think is particularly revealing is Acinetobacter, which I know the industry didn't use very much because it was only discovered in the 1990s after the pharmaceutical industry had already gone into its decline in terms of antibiotic discovery. We also use plant pathogens, eukaryotic plant pathogens. These are a protist called oomycetes, and you can see the first antibiotic that my lab discovered many years ago was an inhibitor of Pythium, one of these oomycetes, and turned out to be zwittermycin, which is not only the only antibiotic starting with a Z, not to be confused with azithromycin, starts with an A, but also had a novel structure that is a novel class of antibiotics. And actually, even though it's been around for a while now, there is no other member of that class. And then we also screen for antiparasitics with a collaborating lab on campus. So because we think that we're looking at a somewhat different scope of antibiotics, we think that we will discover new things. Another thing we're interested in are very narrow spectrum antibiotics. And the focus of the industry, for good reasons, medical reasons, as well as financial reasons, was always the broadest spectrum possible so that, one, they could make the most money off one drug, but also so that an unknown infection could be treated with a broad spectrum drug. Well, I think as diagnostics gets faster and better, we will be able to use a more precise way of matching the antibiotic with the organism, and that might slow the development of resistance because we would be using less of each drug. We use taxonomy. The power of modern genomics gives us incredible power to very rapidly find out the taxa of the organisms. And my lab, the chemistry hub, focuses very much on those that come from organisms that are not known antibiotic producers. So the vast majority of our antibiotics on the market today come from the actinomycetes, one group of extremely prolific antibiotic producers. But it turns out that there are many groups of bacteria that produce antibiotics that were ignored by the industry because they just weren't members of the actinomycetes. We also do a very deep genomic analysis. We get extremely good sequence, DNA sequence data from the genomes of the organisms of interest. We work with the Joint Genome Institute in California that has a contract to deeply sequence at least 500 different strains. And I work with an incredible bioinformaticist who was my postdoc, now a professor at University of Florida. And he has developed very powerful programs to find new biosynthetic pathways. So he can look at the genome and he can find the clusters of genes that look like they would be biosynthetic pathways. He can recognize the ones that are for characterized known antibiotics. And then he can make very, very rough cuts about and choices about which ones are the highest priority, which ones probably produce the most novel and different antibiotics. And so far, he's come up with many. I'll show you some of the numbers. And then finally, we do chemical analysis with mass spec, which since the antibiotic industry closed down in the 80s, mass spec has just gone wildly more productive, fast, and effective There are now compound libraries, just like we have gene libraries, where you can compare the mass spec profile and determine pretty quickly if you're working with a known compound, and you can just toss that one out. And then finally, we found in my lab and others that many of the pathways in these organisms are not expressed. I mean, one great example is the organism that was first found by Salman Waxman that produces streptomycin. Turns out when we finally got the genome many, many decades later, it doesn't just have a pathway for streptomycin synthesis, it has 26 other biosynthetic pathways, but none of them are expressed. So what if we could just take all our known organisms that already produce known antibiotics and somehow turn on those pathways? What a treasure trove we would have. And so what we found with this pipeline is that this is just 22, just an example here, 22 sequenced genomes. We now have about 10 times that. We found 824 new biosynthetic pathways in their genomes. And those are represent a wide array of the types of molecules. We don't know the structures of those molecules from the genomes, but we can make really good guesses at based on the enzymes in the biosynthetic clusters. We can make guesses about the nature of the antibiotics. And so, or small molecules, we don't know necessarily antibiotic activity. And so those are the ones that our chemistry hub follows up on. To further make this collection useful, when we find these interesting biosynthetic clusters, there's no guarantee that they're being produced, that they're being expressed. We found that temperature, growing bacteria with other bacteria, and sublethal levels of antibiotics are all inducers of some of these biosynthetic pathways. And so this is just an example of one of my undergraduates in the lab discovered this. She took 4 isolates, they're shown here, 5, I guess, and you can see only one of them produces a zone of inhibition against Acinetobacter, A. bailey. But when she puts a sublethal concentration, so 1 microgram per mil of streptomycin, which will not kill either A. bailey or the potential producers, she finds that, in fact, now 3 of them produce zones of inhibition on A. bailey. And we have begun to dereplicate this. We don't know the mechanism yet, but it sure looks like stressing and kind of just irritating the bacteria makes them more likely to express their antibiotic pathways. And so we're trying other irritations to see if we can annoy the bacteria enough to express even more. But this was a really great finding by an undergrad that we are pursuing very, very actively, because we know that the antibiotic industry did not use induction methods. I've asked every one of them that's still alive that I know, and none of them knew about antibiotics inducing antibiotic production or co-culturing, any of these methods. So we think that that is another way to take even the old collections of microbes. Maybe we don't even have to have undergraduates collecting microbes from all over. Maybe we just need the old collections, treat them with some of these irritants, and we'll see new pathways being turned on. And so these methods have led to a whole variety of new compounds, some antibiotics and some other kinds of compounds. And we have just geared up the chemistry a lot more with a really terrific chemist. And we're hoping this will lead to discovery of clinically useful antibiotics. The undergraduates are always saying, well, are any of them in clinical use yet? You know, they want to see the people's lives who were saved. And it takes about 10 years from discovery to market. So I think we're a ways off, but we're looking forward to that too. And then finally, when we go back to the uses of soil and the importance of soil for health, besides food, water, antibiotics, and biodiversity, the last is carbon storage. And this relates very strongly to all the depressing news that we think about with climate change. Soil is one of the biggest repositories for carbon on Earth. In fact, it's the largest terrestrial one on Earth. And so just to remind you, because you probably don't think about photosynthesis every day in the work you do, we depend on plants and in the ocean, the microbes. But on terrestrial locations, we depend on the plants to use the energy from the sun to fix carbon from carbon dioxide. That's one of the sinks for the greenhouse gas, carbon dioxide. And what is a little less known is that those plants will often transport as much as a third of their carbon that they go to all the trouble to fix with photosynthesis, an expensive process. They will transport that about 1/3 to the roots and then spit it out of the roots. And on the face of it, that sounds very wasteful. Like, why would they spend all of these ATP molecules to do all the process of using energy from the sun to make all the compounds they make from carbon dioxide, and then just give it away? Well, the reason is that there are soil microbes that live in close association with the plants, benefit the plants in many, many ways. And one of the ways that they do that is that they produce polysaccharides that are essentially ways of fixing carbon in the soil. And so they give soil its texture and its structure. Those microbes are critical for protecting the plants from disease, but also for making the soil itself. So as a result, after all the millennia of plants growing on Earth, we know that about 2,500 billion tons of carbon resides in the top 2 meters of soil. So that's the top soil and just below it. That's a big number and it's hard to visualize, but we do know that that's 3 times as much carbon as is in the entire atmosphere. And it's 4 to 5 times as much as is in all of the plant biomass on Earth. And so if you look at the breakdown of terrestrial, I'm leaving the oceans out of it. The oceans are an important element of our carbon, obviously probably the most important. We also have a lot less control over our oceans than we do terrestrial life. But if we look at just terrestrial life, this is the atmospheric carbon, this is the plant-derived carbon, and this is the carbon in the soil. And so you can see the soil is carrying an awful lot of the carbon load from terrestrial environments. But the sad part is that since 1850, we know that we've lost about half of the carbon that was once in those soils across the world. And that's largely due to agricultural production. So I want to turn now, since I hope I've convinced you that soil is pretty important for human health, and that yes, we do need it, but I just hinted at the crisis we're facing. I'd like to turn now and dig a little bit deeper into that crisis and talk about soil erosion. So this is a very dramatic example of soil erosion in Africa. We don't usually see profiles exposed of many feet of hillside like that. But even when it's a lot less visible and a lot less dramatic, it's a very serious and rapidly occurring crisis. So USDA brags about the fact that we have an estimated 5 tons per acre per year of soil, topsoil disappearing. And they think that that's pretty good because it was once quite a bit more and it has now leveled off at 5 tons per acre per year. But remember, I said before that soil is produced at about 0.5 ton per acre per year. That's really not a sustainable equation. So soil is eroding at least 10 times faster than it's being produced. That is the basis of the crisis. And so when I was in the White House, we wanted to put some numbers on this, and people kept asking, well, how much soil is left? FAO had just come up with this estimate that by 2060, essentially all the agricultural soils would be gone. And that's 30, 40 crop cycles. That's not very far away. And so we wanted to put some numbers on it to see whether is that a reasonable estimate or not for the United States. And so our projections showed that if you took the USDA numbers and accepted that we're losing 5 tons per acre per year, and you plotted that very simply, it would take about 100 years to get to the halfway point where we have about half of the amount of soil starting with a very good, rich, fertile soil like we might have, say, in Iowa. I plot the halfway point here because that's when you really start seeing reductions in crop yields, when the soil gets to be about half of what it was. So that seems like a very relevant number. So 100 years didn't scare people too much. Election cycles are 4 years, so presidents don't usually think about that. That president liked to think about soil, though. And what we found was that that was actually a much more hopeful estimate than reality suggested. This is a picture of a landscape in Iowa. And every place you see these light tan spots, you can see them throughout that area, that is area where there is no more topsoil. So you can see the subsoil poking through all over the surface of Iowa, one of the most important agricultural states in the country. If Iowa were a country, it would have the 7th largest agricultural production in the world. That's pretty scary. One of our most productive states already having lost all of the soil on quite a bit of its land. So even though the average loss is 5 tons per acre per year, it's pretty unlikely that it's that low on average. First reason is that that is an underestimate. The USDA, by their own admission, measures 2 kinds of soil erosion. There are actually 3, the third kind being gully erosion. And it is very, very difficult to study gully erosion because these are gullies that are formed when it rains. The soil drains into them, and then they disappear when the soil dries out. So it's a little hard to track. And people haven't made a great effort to do so. So people think that maybe this is about half. So maybe the average across the United States is more like 10 tons per acre per year. But there's also this landscape variability that you can see right here in Iowa, where some areas are eroding much more rapidly than 5 tons per acre per year. And this was an example. While I was in the White House, there was a soil in Iowa that eroded at 10 tons per acre in one afternoon. It was one rainstorm. And when they realized they were measuring this, they realized how much was disappearing in one rainstorm, one of these very, very severe precipitation events. They started looking across Iowa and they found out that there were thousands of acres that lost similar amounts of soil in that same rainstorm. So that makes it a little bit scarier, and I'd like to tell you one of the reasons why. This is an example of the number of extreme weather events, severe precipitation like we've been seeing in the Midwest in recent years. In the first half of the 20th century. So between 1900 and 1950, it clustered around a mean. And we didn't really see a lot of deviation in the number of those events. But if you look at what happened since 1950, the frequency of these high velocity raindrop events, and it is that velocity that is so critical for causing soil erosion, has increased. There hasn't been a single year that has gone back to that mean, and it continues to go up. And that is thought to be pretty well demonstrated to be one of the results of climate change. So these severe weather events are driving the rate of soil erosion up, but that's not going to just level off. That's going to continue. There's going to be a long tail. Even if we get a handle on climate change and carbon emissions, we're still going to be seeing the effects of increased severity of weather and extremes in weather for many years. So we can probably expect this number of events to go up. And so not only are we underestimating how much soil we're losing, and we're starting to see some of these wild rain events causing the equivalent of 10 years of soil loss by the USDA's average numbers. But now we're saying that there will be many more years that have those severe rainstorms quite frequently. So then we had to kind of revise our estimates and think, well, 5 tons per acre per year really is not an average, most likely, and it certainly is not going to apply to much of the farmland across the United States because of this variability. And so you can see that if we were losing 25 tons per acre per year, which is totally reasonable and possible, we would be out of soil by 2060. We would reach that important halfway point by 2040. That's not very far in the future. And of course, if you go to the extremes and you look at areas that are eroding at 100 tons per acre per year, those will pretty much be out of soil within a decade at most. So that's not going to be every soil on Earth. It's not going to be every acre of every soil, but it certainly will affect some soils that way, because we know that the sloped soils and the soils in areas that are getting these extreme weather events are definitely eroding faster than any average that's been estimated. So we've already clocked that 25% of Iowa's cropland has no topsoil left. So remember those light tan areas that I showed you from the aerial picture? Those can be found in about 25% of the land area in Iowa. That is scary for one of our most productive states. So we have consequences across the spectrum for soil loss. Obviously, the first that we might think of is less land for producing food and lower yields when we do. But there are all sorts of other things. The soil is like a sponge. And so if you don't have strong, healthy topsoil, then there's no buffering in these severe weather conditions that we see so much more frequently. During the droughts, the soil dries out faster if we don't have the sponginess, which is generated by healthy soil. And in floods, there is poor drainage, and we see much more damage. And you can see, based on agricultural practices that generate very strong soils and those that abuse the soils, you can see right next to each other corn plants treated where the soil's been treated one way or the other, where after an enormous rainstorm, the corn plants in one are tall and strong and happy, and in the one where the soil has been abused, they're what we call lodged, which is lying down flat.
Oh, thank you for calling me.
Oh, okay. Sorry, I was taken by surprise by that. And so, of course, we know the population of the world is growing. Probably by 2050, we will have probably around 10 billion people to feed, and we don't want to expand the amount of land that is used for agriculture for a lot of very good scientific and climate-based reasons, but we're just not going to be able to use the current land base and feed that large population. We'll be losing the water filtering capacity as we lose topsoil. The water will pay the price. We'll be losing microbes that aren't found any other place, and we'll be losing carbon from the soil, because when some soil erodes, it releases carbon into the atmosphere. Not all, some take the carbon with them, but a lot of it results in carbon release. So why does soil erode? Well, it turns out it's really simple. There are 3 practices that are the major causes of soil erosion. And that's one of the nice, happy things here is 3 practices that cause it says there should be 3 solutions, and that's about what it is. So the first is plowing. So plowing is seen as by many farmers as a necessary way to start agriculture in wild land that was not domesticated. It's very difficult in heavy, dense soils like we have in Wisconsin to walk into prairies, which are the natural landscape, and start planting crops without a plow. But unfortunately, the plow has been overused. There are farms that will plow 4 and 5 times a year for control of weeds, for planting, for right before harvest, right after harvest. And these deep, what are called moldboard or other kinds of plows, will dig deep in the soil, they turn it over, and they break up the clods that the bacteria and fungi have worked so hard to create. That structure of soil is one of the most important elements of healthy soil, healthy plants, and fighting erosion. So as soon as you start plowing, the erosion rates skyrocket if you don't take other precautions. And there are examples in, for example, Virginia and a whole swath of the Piedmont area in the southeast, where the soil has been entirely eroded off hillsides. And it was done well over 100 years ago, about 150 years ago. Those lands used up their soil in about 10 years. And the people just kept moving further and further west. As they used up one soil, they'd move to the next. And that was entirely due to introduction of the plow.
Sometimes it makes me feel
The next is that we know that the great soils of the Midwest were created by the beautiful prairies. How many people here have even seen a prairie? Oh, that's good news. Okay. Well, a third of Wisconsin used to be covered with prairies. Now it's barely 5% of Wisconsin. So it's actually hard to see prairies, or at least original prairies. So I'm glad to hear that many of you have seen them. This is important because those prairies generated the soil that we have in a way that crops will never do. And modern crops will certainly never do it because we have bred the root systems out of them. So we breed a corn plant. Since 1920, we've been breeding corn plants to make hybrid corn that produces a lot of ear mass, right? We want the seed to feed cows and people. So that has resulted, not intentionally, but because nobody was paying attention, in these teeny weeny, puny, very sickly root systems. And so we have sacrificed the root system to get all this biomass above ground into the harvestable material. Well, the result is that this corn plant is not feeding the soil the way a plant should. This is an example of the kinds of native grasses that we used to have. This is switchgrass, and the roots of switchgrass have been measured to more than 14 feet. Okay, this one is only probably 7 or 8 feet, but they have been measured penetrating the soil so deeply, and it's not just deep, it's the density of the root mass that contributes so much to the soil. One of the key elements of the original prairies is that they were populated by perennial plants that store carbon in their roots over the winter, and then they come back the following year using the energy that they stored the previous season. And so we have gone from these healthy perennial crops that feed the soil to ones that are estimated by some of my soil science colleagues to take about a pound of soil away for every pound of corn that we produce. So we have plowing, we have annual crops and small root systems, and finally we have lack of cover. And lack of cover is something you should never see. You fly over the Midwest, you see lots of soil like this at this time of year. Before it gets covered in snow, it's often been plowed and then just left open. That leads to both water and wind erosion and is extremely easy to fix. So we've made this perfect storm for erosion. We can turn that storm around and take lessons from the indigenous world. There are societies like the Maya, for example, in Mexico and Central America, who have been living on and doing agriculture on their land for thousands of years. The Maya look like they go back probably 4,500 years. They have been practicing agriculture in the same site. We can't even keep going for 100 years in much of the United States without destroying our soil. And there are many examples of this. In fact, essentially all of the indigenous cultures that are still around are either hunter-gatherers, and there are very few of those, or they have sustainable agricultural practices. So what do we learn from looking at them? Well, first of all, they use a no-till kind of planting, so they're not tilling or plowing the soil. They use cover cropping and do a combination of cover crops and mixed plantings so that they're getting many different plant species in the same area. And this is an example to contrast with that bare soil. This is an example of a cover crop that is planted after the harvest of the main crop. It's allowed to grow for as long as it can until frost. And then it's either left or sometimes it's harvested depending upon the crop in the spring. And in the meantime, it holds the soil down, it nourishes the soil and feeds back to the soil what the crops have taken out. There are wonderful experiments going on which show that you can take 10% of corn, the corn plant, out of production and replace it with prairie plants. So these small strips of prairie plants will reduce erosion by 90%. So we literally could turn this around in one cropping season by using not tilling, planting cover crops, and then doing some sort of mixed cropping like this, which only takes 10% of the corn. But we are so perverse that I found out when I was in the White House why that isn't done. And it's not a happy story. But the rest of the story is happy. We can practice all of these changes. I hope I've convinced you that soil is essential for the health of people, for food, antibiotics, and ultimately for the planet as well, because it will help us fight climate change. The soil is eroding quite rapidly and probably more rapidly than we're even saying, but we know how to save it. And the question that many of us have is, will we do it in time? As a species, we're not that good at planning ahead and fixing crises before they take over. We tend to be reactive. So let's hope this is one where we don't let all the soil get away before we respond. Thanks for your attention.
Thank you very much, Jo. Is this on? Can you hear me? You have truly driven home the interdependence of human health, planetary health, soil health, and its meaning for our future. One of the questions that came up is, and this is probably a whole other lecture, but could you briefly speak on, I know you've done some work on the human microbiome.
Mm-hmm.
Could you briefly speak on the connection between this and the human microbiome?
So the human microbiome is probably the second most complex environment on Earth, soil having the greatest diversity of species, the human microbiome being extremely diverse. The human microbiome is a driver of human health in ways we never anticipated. And you know this well from your husband. We're even finding, in a collaboration with Susan's husband, that the human microbiome changes as a result of practices that change depression. And so that's just one crazy example. Who would have ever thought that, right? So the question that's been asked many times, because there's always been this enormous divide between agriculture and medicine, but many people have asked, well, what does the soil microbiome do to contribute to the human microbiome? And just stray observations are things like kids eat soil all the time. Most people say kids eat dirt. Don't say that. They eat soil all the time. Well, maybe they do that because they're populating their microbiomes. We don't know if that's true or not. We also know from experiments that were done here at the medical school, fascinating work with the Amish that shows that the human microbiome is dramatically influenced by how much contact kids have as they're growing up with the animals on their farms. And if they use animal-drawn implements on the farm, they have a very different and healthier microbiome than if they have grown up with equipment on the farms where there aren't animals. That ultimately has enormous implications for the soil. The soil influences the animals influence the soil. And the answer is we don't know the answer to your question, but there are these tantalizing hints that suggest that there is a strong interplay. Obviously, an indirect one is the health of the soil directly affects the composition of the food supply. The composition of food will affect the microbiome. But many of us think it may be even more direct than that, of soil microbes actually colonizing the human gut. And in fact, the National Academy of Sciences is currently doing a study on exactly that question, because they realize there's just this enormous gap in our knowledge. So hopefully when I come back in a few years, we'll know that one.
Thank you. And in the interest of time, I think we won't have any more questions, but Dr. Handelsman email is on her website. So.
All right, thank you again. So we are going to transition into our environmental justice and advocacy panel. Beth is going to be a moderator, so I'm just going to go ahead and pass this right on off to her.
So can I have the two members that are here come down and sit at the table? And then one of our participants is online, and they're actually going to be first. So let me speak for a moment and say that this is where the rubber hits the road. I have the greatest admiration for the community advocates. And if you look at the history of Louise Gibbs at Love Canal, she was the one that helped firestorm the start of the EPA Superfund. She was a housewife, and she was just an amazing advocate. And I just want to say one more thing. We have an advocate that I want to dedicate this to. Her name is Maria Powell, and she has been a force in our city for standing up for environmental justice, whether it's PFAS, whether it's chemicals by the KIP plant. She's been an amazing advocate for 30 years. And the reason I want to dedicate that to her is she is currently dying of pancreatic cancer right now. And she's been an amazing person for our community. So I just want to thank Maria Powell. So with that, it's time to introduce the current community advocates. And the first person I'd like to introduce is joining us online, and it's Tamika Glenn, who is the Chief Program Officer of the Coalition on Lead Emergency in Milwaukee, Wisconsin. Tamika, thank you for coming today, and tell us the amazing work that you're doing in Milwaukee.
Hello, everyone. My name, like she says, Tamika Glenn. I am the Chief Program Officer for CO's Lead Safe and Healthy Homes project here in Milwaukee, Wisconsin. Our primary focus here is to provide the necessary resources and education for the parents in Milwaukee County, but we specifically look at the 53206 and 53205 zip code areas that are really plagued with a lot of our lead poisoning cases here in Milwaukee. So with that being said, here at Co's Lead Safe and Healthy Homes project, we provide lead-focused education. And when I say that, I mean, we just don't provide pamphlets. We do more of a hands-on approach where we actually do referral processes because a lot of our children in the city of Milwaukee do not have primary care physicians. So we have a referral process with our local hospitals here where we're able to give a lot of these parents a referral for primary care physicians. And we also are doing a cooking class here because we are finding one of the best things that we can do for our children is provide them with a lot of vitamin C to pump the lead out of their bodies. So we have our what's called Cooking with Cold classes, where we actually find recipes that take under 20 minutes and sometimes under 30 minutes to prepare for their families. And they are very rich in a lot of healthy nourishments and proteins and vitamin C's that help the children to pump the leads out of their bodies while they're being active and at the same time make them fun. So we have that every other Monday here at our partners, Helpatha Lutheran Church on 18th and Locust. We don't just provide them with the program and the education, we also do lead testing for a lot of the parents. And we also provide other resources like workforce jobs, or either groceries. We also give them 3 bags of groceries that they're able to take home at the end of those classes. By the end of those classes, we have the recipes set up for them to take with them step by step. And we also show them how it can be cost effective to help, dial back on some of the resources that's required in the house. So a lot of fresh fruits, vegetables, and things like that, we try to push the most. We kind of steer away from a lot of the meats and sweets and everything that the children shouldn't have. So that is one of the pieces that we do here at Cole. But I'm going to back up a little bit here and just really start with our advocacy work. All of this ties together because we're advocating for these families to be able to know and get information about what's going on around them in their areas, because a lot of the kids are being diagnosed with certain ailments or behavioral health issues and things of that nature. And we're finding that a lot of the kids are having elevated blood lead levels that's causing these misdiagnoses. So one of our primary focuses is the awareness piece and the advocacy piece, because a lot of the parents here are not aware of what's going on with the lead, and then they're not asking their doctors to even test the kids for lead poisoning. So we're not only making a call to action here, we are actually pushing and helping people to make that call. So here at Cole, we are definitely pushing the advocacy piece, but we also know that in these 2 communities is other resources that's needed as well. So we work with our workforce development groups here in the city of Milwaukee to try to get a lot of the families to help themselves and basically become lead abatement specialists, where they can learn how to abate their homes from all of the lead and actually get a job doing that within some of our local construction crews here. So it's kind of like knocking out 2 birds with 1 stone, basically, and actually helping them with a resource to find employment, and then also help them to be able to take care of their families. And that was one of the main things that actually got me started, excuse me, within the lead poisoning program. I actually started this program in 1998 in 53206 zip code based upon asthma. Asthma was really affecting my household personally, because I had 2 kids that I found out that had elevated blood lead levels. But it was because of a lot of the dust and different things they were ingesting. So it was kind of setting off their triggers for their asthma attacks. And I just kept wondering why. But then we actually found a source within Family House that was actually doing lead abatements already. So I wanted them to test it out and just see what was going on in my own household. And my kids were diagnosed with cognitive delays, behavior health issues, speech problems, high blood pressure at a young age. I had a lot of different things going on, but it just really made me aware of my surroundings and what was going on, and which entailed me to actually bring some action, bring some awareness, because I found out a lot of my neighbors didn't even know what was going on within their community and what was going on within their households. And within the first year of actually doing this work, I was able to find 29,000 children that was being affected by lead poisoning. So it really piqued my interest to see a little further what was going on, which helped me to start a lot of the landlord-tenant discussions around lead poisoning. And I kind of went away for a minute when all of the funding left, but it brought me back this time, and I actually seen that what I was doing back then has actually doubled in size. And so I can see myself always being in this until we get the job done. It has been a big blessing for me to be able to come here and work for Cole, to be able to do the awareness, the advocacy work, the education components and different things that I can do to help other people, and also provide them other local resources like food and job security and rental programs and different things of that nature. So like I said, here at Cole, that's one of our primary focus is education and awareness, and working with a lot of our birthing and lactating moms to bring awareness to them that they also can be affected by this, and children can be born with lead poisoning. So we have here our birthing and lactating moms program, where we're able to help a lot of the moms with lead safe kits and water filtration pitchers, so we know that they're drinking healthier water, or they're able to get the lead cleaned up out their windowsills and different things until their homes are able to be assessed to see if they even qualify for the abatement program. So here at Cole, we're definitely focused on anything that has to do with lead, but not just lead, also resources, because we know, you know, lead poisoning with our kids is always put on the back burner because of a lot of the parents not being aware of asking for these tests. And we think that should be a requirement when our kids are actually getting their yearly examinations. So we are fighting for the awareness, the education, and the advocacy here at Cole. And I appreciate everyone for listening to me and just allowing me the time to be able to tell you what's going on here within our organization. If you want to volunteer, if you want to help, or even if you want to have a discussion, we can definitely be reached here at Cole Lead Safe and Healthy Homes Project, Monday through Friday, 9 to 5 p.m. If you have any questions, concerns, or even know someone that may be in need of help or assistance. Thank you.
Prove that their home was lead safe prior to be able to rent. Baltimore has that regulation. We could not pass that in the city of Milwaukee because of state regulations. You need to write to your representatives in the state and say the real way that we can help our Milwaukee children is to make sure that those homes are lead safe before those children are in those homes. Right, Tamika?
Correct, definitely correct. It's just, you know, even a block away from here, it is a house that we know you can just literally ride up to the house and just know that the kids there are definitely in a place that they shouldn't be in. Even around the paint, the chip and paint from the outside is actually getting into the soil, which gets on the bottom of the feet, and we are tracking it in our houses. So I definitely wish that more people would write out about this, bring more awareness to this, and understand that this problem is not going away.
Thank you so much. Thanks for coming today.
Thank you for having me.
Okay, so our next speaker is going to be Adrian Nino, who represents Stoughton Healthy Children and Neighborhoods Alliance from Stoughton, Wisconsin. Thank you, Adrian.
Hello, can everybody hear me? Is that working? Well, I have two mics. Should I turn it on? I don't know, can people hear me through the mic? Yeah. Oh yeah, you can? Okay. Okay. Hey, hi. Yeah, so I'm here from Stoughton today to talk to you all about a little bit what we just heard about, how state law can impede local action or change in local policy. That's relevant to what I'm going to talk to you all about here today. So in this particular instance, we were dealing with a quick trip mega super big gas station that wanted to build a new gas station, super mega convenience store and car wash right next to a daycare facility. And also in really close proximity were 4 other childcare and daycare facilities. So I didn't really know how terrible of a situation this could be. When my husband and I chatted about it, when we found out from the daycare director where our 2 children go to daycare, we were like, oh yeah, we don't want a gas station next to a daycare, you know, creepers. And we didn't really think about all the broader health impacts, the negative impacts of a gas station. But I decided to go to a public hearing to kind of learn more and just be a part of the conversation. And at that public hearing, an internal medicine doctor who had an MD and a PhD, who she was retired, but she lived in the neighborhood that would also be affected by the gas station. And she talked about these health impacts. And I thought, whoa, I had no idea. And we have to do something about this. We got really, really, really lucky. And we're given 6 weeks to try to figure out how to stop this from happening when typically a vote would have taken place that night. So there was a little glitch in the report or the system of notifying residents and things. So we got really lucky and we had 6 weeks to uncover the burden of proof. And I'll talk a little bit more about this. How do we, is it turned off? Well, how many of you know what a conditional use permit is? Okay, we have a couple. Okay, so a conditional use permit is a permit that will allow a specific type of land use that otherwise wouldn't typically just be allowed in a city's code of ordinances per se. So certain conditions have to be met in order for something like a gas station, fuel stations to be allowed on a parcel of land. So typically this hasn't been a big problem, but back in 2017, all energy, like mining, fracking, stuff like that, was denied a permit in northern Wisconsin in Trempealeau County. And they sued, and it went to the state Supreme Court. And even though the Supreme Court upheld the decision, there was one dissenter on the opinion which changed state law across the state of Wisconsin, which now requires that any city, village, town decision to approve or deny a permit must be supported by substantial evidence. State statutes define substantial evidence as facts and information other than merely personal preferences or speculation directly pertaining to the requirements, et cetera, et cetera. We were lucky in Stoughton that our code of ordinances actually would maybe allow us to provide the substantial evidence, the burden of proof, the facts and information to hopefully get this permit denied. We had language in our ordinance that there could be no undesirable impacts on nearby properties, the environment, nor the community as a whole. And the specific regulations for gas stations in our ordinance meant that we needed to prove that this gas station would exacerbate the potential for pedestrian and vehicular conflict or endanger public safety. So we took that to mean health. Health is a public safety issue as much as vehicle pedestrian conflicts. We can go to the next slide. That would be awesome. Thank you. So anyway, just to kind of give a little bit of context on what we were facing, this was going to be a really big one. 20 vehicles could fuel up at the same time, 64,000 gallons of storage underneath. It would be estimated that about 4,000 vehicles would visit this gas station every single day, a bulk of those trips being in the morning when children are being picked up and dropped off. So we had a good case for those potential conflicts of a vehicle running over a child and an evening. We can go to the next slide. So we put together what we called an adverse impact assessment. We conducted a lot of research, and we said that putting this gas station 100 feet from the door of a daycare with 180 children and within 300 to 350 feet of a lot of other children and homes would exacerbate the health of children at the facility, the school. There was a 4K program involved here. We focused a lot on BTEX compounds, benzene, toluene, ethylbenzene, and xylene, neurotoxins, and carcinogens. That was a really, really big argument. We focused a lot on that. We touched a little bit on air traffic pollution, for, the burning of the fuels and the amount of traffic in and out. But we did a lot of BTEX. And we focused on traffic and everything too, but we can go to the next slide. What came out of this was we kind of engage in a whole community engagement exercise, inviting people. This was a not in my backyard issue, right? So how do we get more people in the community to care about something that doesn't really impact them all that much unless their child goes to the daycare or they live in the adjacent neighborhood? So in addition to having this goal to stop this permit from being approved, we wanted to work to establish safety zones in the ordinance. So new regulations in the ordinance to guide gas stations toward locations that they're better suited for. So not next to where vulnerable populations would be breathing a lot of these volatile BTEX compounds, which are easily vaporized into the air all day, every day, in pretty high volumes. So we're still working on number 2. It's not going well. We're hitting a lot of roadblocks, but we were successful in stopping the original permit back in April. We've been trying to work with the city, the staff and representatives ever since, and we need to do more. We can go to the next slide. One of the things that we had on our side is I'm in science communication as a profession. I work at UW's College of Engineering, actually. And so I was able to take a lot of the experience that I have in that role to try to communicate these facts and information in ways that would connect with broader audiences of people. And one of the things that I do in my day job is I create graphics. So this was one of the graphics I created to try to show all the various ways that these BTEX compounds are vaporized into the air, and how they settle down toward the ground, and how this would be a really bad problem to be next to young children. I failed to show that these underground tanks actually leak. So I need to add that to that graphic, but anyway, we had all these other graphics too, trying to show the proximity, overlaying the site plan on top of the site, trying to measure distances using ArcGIS software and maps and Google Earth and everything to try to make sure that the information was nice and clear and easy to understand. You can see the blue are all the childcare facilities. Next slide, please. This particular site had major traffic safety issues. There was a blind hill that came up to the daycare, and if you were turning left out of one of the residential streets from the daycare, you did not have enough time to make a decision about whether or not you should make that turn. So we tried to prove that this increase in traffic would make this already bad problem much worse, which in the next slide, you can see the bar graph we created about the increase in traffic and the traffic being diverted to the left turn, and et cetera, et cetera. all this to say is we did a lot of work. We had the privilege of having access to a ton of resources. As a UW employee, I support in my job, traffic operations and safety engineers. I was able to lean on them for some guidance and support. They guided me to some research and information and equations so that I could put these together. We were so lucky. This was a hard fight. We lost a ton of sleep. I had some other parents really in this fight with me along the way. That's why I say we. And we still, I feel like we had it made. We had 6 weeks. We had access to resources. We used them. We leveraged them. And still, the Friday before the public hearing, which was on a Monday evening, I spoke to an environmental attorney one more time. And he said, well, do you have any expert testimony? And I said, no. And he said, you don't have a chance. And so I called Wisconsin Environmental Health Network on a hope and a prayer. And within 30 minutes, I had a call back from Dr. Neary, and she said, I've been following your story and I want to help. And it was a game changer. I still have Plan Commission. It was a joint hearing. So I still have Plan Commission and city council members come up to me and say, that was so powerful. That was so powerful what she said. We had 16 people. We had an orchestrated, organized public testimony across all of these adverse impacts. We had poster boards and printouts so that we can, show the visuals as we spoke, but still having the expert there in the room to really tie it all together made such a big impact. So if there's any takeaways for any of this today, it's that Beth showing up and giving her 3 minutes of testimony was so valuable. And so if any of you want to take, was it Dr. Maibach's call to use your voice, you should.
Maybe a little closer.
Okay, all right. Thank you so much, Adrienne. She did the bulk of the work. I only did 3 minutes. Okay. Our third amazing community advocate is Lee Donahue, who I had the pleasure of being on the PFAS advocacy committee with. It's a statewide committee. She is a member of the town board of French Island, and she's going to talk to you what she's doing for her community with regard to PFAS.
So, first of all, I thank everybody for being here today and making time in your very busy schedules, because today's important and what we all do is important. Putting a face and a story together is important because that's how we connect with other people. We can spend a lot of time putting stats and ordinances and graphs and data together. But sometimes it's when we put that face on a story about a child who has cognitive difficulties, has behavioral difficulties, has medical difficulties. When you put the face on it, people can somehow relate, because no matter where you are on the spectrum of the political party, you can relate to a child who has difficulty breathing, right? Just on a human basis, we can connect to that. About 3 years ago, a neighbor of mine said, hey, there's a vacancy on the town board, and I really think you should apply for that. And I said, town board, I don't know. And they said, it's 1 day a month. You go to a board meeting and it's 1 hour, you'll be done. And I very naively believed her. So I became a town board member, and within about 5 months, we got a phone call from a neighboring municipality that said, by the way, you may possibly have PFAS in your water. It possibly is unsafe to drink, but we really don't know. And I said, P who? And they said PFAS. And then I went to Google. And sadly, what I discovered is that PFAS is highly toxic, and it can change people's health and their lives in ways that we're uncomfortable talking about. It's toxic. I mean, that's the bottom line. And I quickly had to get up to speed. And by the grace of God, I met people like Dr. Neary and many others who helped me get up to speed really quickly. My background is a journalist, and so I'm a researcher, right? I'm really good with facts and figures and data and graphs and all of that. But this was totally new territory for me. And so the one thing I tell people is that if you don't know what's in your water, whether you're drinking municipal water or you're drinking water from a private well, find out. Because what is in your water is affecting your health. So I live on a tiny island, which is only about 4 square miles. And it's not lost on me that that's very close to 3 miles and 3 Mile Island, but I digress for a minute. We live in a very small island in the Mississippi River. We're hugged by the Mississippi River. We're hugged by the Black River. And it is the most amazing place to live because there's only about 4,300 of us. And we have an amazing police department and fire department, and it is so incredibly scenic. I live 3 doors away from the water, and that means a lot of canoeing and kayaking and ice skating during the winter and snowshoeing and all of the outdoor things that I really, really, really love, but I can't turn on my tap and safely drink what comes out. And like so many other families on this very small island, we didn't know. We had no idea. The neighboring municipality knew because they actually tested their water in 2014, and they found out that one of their city wells that was located on the island was contaminated. And 2 years later, they tested another city well on our island and found out that that one was contaminated too. But we didn't find out until 6 years later. And that's really hard to think that you have potentially been drinking contaminated water, not only for 6 years, but for 50 years that the city that is adjacent to us conducted firefighting training activities with AFFF, which we heard about earlier today is a very toxic form of firefighting foam that is laden with PFAS. And it wasn't limited to one area of where the fire department was conducting their training. We've had plane crashes on the island as early as 1970, that the front page of the La Crosse Tribune shows this huge plane covered with white dripping foam that looked like melting snow. And then there was another plane crash, unfortunately, with 2 deaths in 2001. And then there were just a multitude of training events where this AFFF was used. And sadly enough, in the 1970s, the city who owns the airport actually reached out to neighboring industry asking for their hazardous waste so they could use that hazardous waste in their burn pit activities. And this is after, right, the Clean Water Act. And they just brought it all and they used an accelerant called trichloroethylene, and they covered it, and it made really big flames that would be representative of what perhaps a plane crash would look like. And all of that leaked right down into the ground, into the soil. These were not lined burn pits. This was just on sand and gravel, alluvial soils. And it went right down into the groundwater. And now the place that I love is contaminated, and that all of the families that live there can no longer safely drink the water that comes out of their faucet. My sister-in-law insists upon using a hot tub, which to me is like basting myself in PFAS. I can't see that. And it's very difficult because you see the cases of cancer in our town, in our region, in our neighborhood. 2 days ago, we lost a close friend who died of pancreatic cancer, who was diagnosed just a month earlier. And as I drove down here yesterday, I found out that another neighbor just died of cancer in his 50s. There are a lot of people in my town who are dying in their 30s and 40s and 50s. I don't want anybody to die before their time. And so what I say to you is that your voice is powerful. Your voice is powerful. And without your voice, right, we're a handful of voices that are saying this needs to stop, right? PFAS needs to be outlawed. It needs to be banned in the state of Wisconsin, unless it's used on that Teflon gizmo in the mass spec that nobody's going to lick, right? Right? It needs to be banned. There's no reason for it to be in our consumer products. And whether that's mascara or a fast food wrapper or my toilet paper, really? We lived with toilet paper before PFAS for years and years, and I have to say we all seem to have survived. And so if you have not reached out to your legislator, and I beg you to, and anybody who's here as a student, right, you are eligible to vote. Please know that. You are eligible to vote as students, either in your hometown or here, places that you live, that you have residence, to talk about the things that are most important to you. I'm in my 60s. I hope to be around for a long time. But in case I'm not, right, I'm relying on every student here to make these important to you and to your friends and to every eligible voter, to say, you know what, in the state of Wisconsin, we're fighting a lot of legislation on PFAS right now, right? We're fighting that there are people trying to undermine the authority of the Department of Natural Resources. We're fighting people in Wisconsin manufacturers and commerce that are saying, don't restrict what we want to manufacture, right? Just deal with the fact that you live next to some place that did things that led to the poisoning of your groundwater. And it's not just your groundwater. I have a raspberry patch that's about as long as this wall and about as wide as this first row. And I can't eat those anymore. I have people who have apple trees. If I want to grow any plant in my backyard, I've got to put it in a pot. I've got to bring in dirt, soil, nutrient soil from somewhere else. And then I have to water it with rainwater because I can't use my garden hose, right? It's a total change in your quality of life. When you have to have a separate bottle of water next to your toothbrush to know that you're rinsing that and your mouth with something that's safe to drink, right? And every time you fill up the water dish for the cat or the dog, or you go to the stove to boil water to make macaroni and cheese, like every single thing that you do with water. We know that water is the staff of life. And not only is our aquifer contaminated, right? That soil is contaminated, right? That's not the soil that we want people to be using to develop our next antibiotics. And PFAS doesn't just stay in one place, right? It's not right here, and I can just block it from the rest of you, right? It's highly mobile. It moves in the soil. It moves in the water. And what's in Campbell today is likely to be in Campbell for 100 years, but it's on the move as well, right? It's moving to the neighboring municipalities all around me. There are more than 102 communities in the state of Wisconsin that have PFAS contamination. That's more than 72 counties in Wisconsin. This is a huge problem. And if you're not aware of it, I really recommend that you Google it and you do research on how prevalent PFAS contamination is in Wisconsin. It's absolutely enormous. And we have to stop it. We have to stand up and say, I will not allow these chemicals that are so toxic to be used in production of commercial uses, of whether it's mascara, whether it's bottled water, right, that you get at the grocery store. That's not tested for PFAS, just in case you didn't know that, right? The FDA does not test bottled water, right? Our foods, like a lot of our foods, we don't know how much PFAS, what levels are in there. And so the biggest impact you can make is to talk to your legislators, to talk to your neighbors, to talk to your friends, to talk to your families, and ask them to really go to bat and say, we deserve better, right? We deserve better. And our children and our children's children deserve better. You have to have the energy and the time to make this your mission. It's more than 1 hour a month. It's become a lot more than 1 hour a month. And if I could put more than 24 hours in a day, I would give more, because it's something that's worth fighting for. It's worth protecting your health and the generations of people who follow us. So thank you for allowing me to be here.
Thank you, Lee. That was great. So does anyone have any questions for our panelists? I think they did a great job of explaining. Following up on what Lee was saying, our neighbor to the west, Minnesota, and by 2025, they have legislation where they're going to remove PFAS from cosmetics, furniture, dental floss, ski wax, et cetera, et cetera. Our state has nothing like that. Write to your legislators and say, what's wrong with Wisconsin, right?
Right.
So anyway, well, I hope you could all join us now. Jed, will you want to make some ending comments?
All right. Well, in honor of Graham Peaslee, who was a physicist, James Clerk Maxwell was a physicist in the the 1600s. And you may have heard of Maxwell's equations, you may not have, that's okay. But I'm going to use a quote of his. I know the tendency of the human mind is to do anything rather than think. Well, I'm hoping that we were successful in bringing together excellent speakers from all sorts of different perspectives to give you something to think about. Whether it be the fact that PFAS is ubiquitous, a lot of it is never measured, and that there are substitutes available, and that we need to, really lobby and, by our purchasing practices, and, try to avoid them, but also to help others that we know avoid them. From Dr. Maibach, we got we need to use our voices. We know that climate change is real, it's bad, that all the experts agree, and that a lot of people care about climate change. We're not in a minority. And there is hope, and that it's important that, that every 1/10 of a degree is going to have increased health effects. And we need to keep that in mind as we motivate ourselves going forward. So we need to decide how we use our voices, what we need to say and to whom, and, to build political will. Severe soil erosion ties in with climate change as well. We heard about the impacts of soil. And, one of my concerns with regards to climate change is, not only will is there soil loss, but there's also the potential for, crops to no longer be able to, do photosynthesis. The Amazon rainforest may get to be too hot to exist. There are a lot of things that, so those are those, worst case scenarios. But and then we need to recognize that no matter what environment or what community you're in, there may be hidden hazards out there, and that it's important that we try to bring a state of knowledge to folks with regards to what those potential hazards are. Those hazards, tend to impact those who come from marginalized communities or impoverished communities, and we need to, be willing to, be able to take a perspective that, in the name of fairness, justice, whatever, we need to be able to support those communities as well as support the communities that are around us and that we personally love. All right. And then finally, I guess I would say, I will reiterate the fact that we need to recognize the importance of government policy, and that it is not that hard to make your opinion known to your representatives, whether that be a representative in the Assembly or Senate in Wisconsin, Congress at the United States level, whether it be a regulatory board like the Public Services Commission. We need to make our voices known so that those people realize that they are being, asked and tasked with protecting human health. And with that, I'd like to say thank you to everyone who spoke today, and for sharing your knowledge, your perspectives, and for the other members of my committee. And anyway, that's about all I got to say. All right.
Thank you. Okay, so just once again to thank everybody for coming out. We really appreciate you. If you have any and all feedback, comments, we encourage you to fill out a conference evaluation form. We have an online, completely anonymous too. Reminder that if you are a CME credit recipient, that you are required to do that in order to get the credits you generously paid for. Also, please join us for our social hour. We have some really good refreshments and some snacks in 1222. It's going to be across the hall, a little bit to the left. Claire should be there already. I'm sure most of you know Claire. Yeah, thank you again. Have a great weekend. And thank you for those on Zoom who have stayed with us.